Right, guys, so Rajiv here from Math Vibes, and we're going to be looking at some January and June paper threes to help any paper three exam for June 2026. So, I just let you know that it's real vibes here. And if you're staying quiet, I'm going to knock all your woody vibes, right? So, you don't know the proceedings. It's real vibes here. Talk, make jokes, and understand the maths. So, let we drive straight into it. Wait, I don't know why you're not seeing the screen. Uh, Give me 1 second. It's kind of weird. Mm, okay, nice. So, some things first. What do you need to know for the CSEC Maths Paper 3? Does anybody know? Does anybody know what you need for the Maths Paper 3? Anybody know?
Yes, sir.
All right, so the Maths Paper 3 could be any two questions, really, from the paper 2. Any two. But these are the main ones you should focus on. You should focus on measurement and geometry, algebra and functions, statistics and data handling, relations, functions and graphs, vectors and matrices, consumer arithmetic, investigation. If all you want, take a screenshot of this now, because these are the topics that will come for paper 3. So take a screenshot now. If you have the screenshot and you're ready to move on, let me know.
Yes,
Yeah,
sir.
guys, I'm live on YouTube. Go check me on YouTube. Okay, I'll have the screenshot. People that was in the crash course that have the paper 3, and I hear Camille, Akira. Well, Akira, you are right at paper 3?
Yes, sir.
Okay, well, take our screenshots. So let's move straight into the January
I already
2026 paper. Okay, nice. So I need a volunteer. I don't know how this goes, so somebody give this a read. Yeah, this is a paper 3 life, but it will benefit you for paper 2 topics as well. So I need somebody to give this a read. Everybody's so quiet for boy. I hit a little vibes or something
Yes,
wrong.
sir. Yeah. You want me to read it?
Yeah, get a read, get a read.
All right. Plaxton owns and operates a small business. He does plumbing, mostly in the countryside. Out of a well-stocked mobile unit, he does not have a fixed way in which he calculates the cost of a job. Plaxton's clientele has increased, and so he needs to develop a model that he can utilize to quickly determine the cost of a job.
Wait, boy, so this man had to learn
The
some
following
maths.
information is provided to you.
Yeah, boy.
The
Yes,
length
Michael?
of a job in hours.
Yeah, Michael, you see the man don't know any maths.
Yes,
He
sir.
he had to learn
So
some maths. Watch, watch, watch. He does not have a fixed way in which he calculates the cost of our job. But we gonna calculate that for him. So, Michael, talk to me. You have
yeah.
any, yeah, you observe anything from this information
Um,
just by looking at it? Let me know if you observe anything.
it could be
Okay, I see a mute. I'm not hearing you anymore. Hmm. When we look at this information, guys, are you seeing anything about it? Probably like the rate at which it's increasing.
it could make so is one
Yes, for
hour.
hour.
Okay, are they kind of shaky? But essentially, it looks like a linear relationship. And why am I saying that? If you look at the data in the table, the cost is going up by how much? I want a little look at it and tell me if you're seeing something in common. So, like we have 130, 210, 290, 370, 450, 530, 610. So,
By 80.
by 80. And Nikolai, isn't all of them going up by 80?
Yes, sir.
So you understand why I say that this was a linear relationship, because it has a constant change. Like a line has a fixed gradient. So we can see that we might have to plot a line. So let me fully understand that.
Yes, sir.
Okay, good. Are you seeing that the rate of change is the same for every single entry in the rows? Let me
Yes,
fully
sir.
seeing that. Okay, good. Again,
Yes,
that
sir.
suggests a linear relationship. So let's check out part A. Claxton must carry out an inspection for each job and must discuss findings and options with customers before he begins. The inspection cost is fixed and is included in the final payment for a job. Using the information provided, plot a graph of cost versus time on the grid shown below, where T represents the time taken in hours to complete a job and C represents the total cost of the job in dollars. Now, Nikolai, I want to ask you something, right? Just by looking at this table, you're seeing that the cost is increasing by a same number, 80. 80, right? The money value is seeing that, 80.
Yes,
So what do you think would happen
yes,
if
sir.
I backtracked here? What is 130 minus 80? 130 minus 80. Does anybody
50,
know?
sir.
130 minus 80 would be 50. And what is 1 minus 1? I want somebody to tell me that. What is 1 minus 1?
0.
0. So at 0 hours, he would have charged what?
50.
$50.
Okay, so let me try to connect all the dots here. So we're seeing a linear relationship, and we have length of a job in hours. Now, as the hours increasing, the cost is going up by $80. But when we backtrack a bit, you're seeing that 130 minus 80 is 50. So if you guys had to think, right? If you had to think, after reading this piece of information, what do you think that 50 has to do about? What do you think that 50 is? That 50. If you had to figure it
Like
out.
the
Yeah,
flat inspection rate or something.
I agree. Nikki, let me know if you're seeing that. So Nikki, when you look at the table over here, and you see that as the length of a job increases, the cost increases by $80. Let me know if you're seeing that.
Yes, sir.
Right. Now, if
Yes.
we were to take away 80 from
Yes.
130, what would that be?
50.
Yeah, that would be 50. And if you take away 1 from 1, what would that be?
That would be 50.
What's 1 minus 1?
0.
Ah,
0.
so you think you could figure out what that means? So it's saying that 0 hours is 50. Hmm. But
So, and, and then probably the $80 is for the inspection.
nah,
And that how
$80,
it becomes a 150.
nah, the 80 wouldn't be for the inspection. The 80 looks like it'd be for the job because Nikki, as the length increases, the cost is
Yeah.
increasing by $80. So that 80 looks like the cost somebody is paying for per hour. If you understand what I mean.
Yes, yes.
So as you're seeing, with the time, as the time increases, what increases? As the time increases, what increases there?
The money.
Yeah, the
cost?
cost. The cost. And so if you guys had to say, what do you think the hourly rate would be? If you had to guess, just pure logic here,
$80.
I would say $80. So just from looking at this table, we could infer that the person has to, like, for every hour that goes by, you have to pay $80. Cool. And from the table, we saw that if you backtrack a bit and you take away 80 from 130, you're going to be 50. And that would imply 0 hours. So that 0 hours is like a flat, okay, the man didn't do any work yet, but he's still getting paid. And if you read this part over here, it says that the inspection cost is fixed and is included in the final payment for a job. So Nikki, the inspection cost. If somebody, here this, oh, you know how AC miners work or not? The money for you know how
Yes,
AC miners work.
yeah.
Or like even stuff like them laundry man and thing. That's fixed like the machines, like washer, dryer and thing. And they would charge a fee just to check it out. And then they would start to fix it.
Yes.
Yes, sir.
Good. So from this table alone, I could infer that, maybe he would have had to, maybe I had to pay him $50 to inspect it. And then if he decides to fix it, every hour that goes by, you had to pay him 80, 80, 80, 80. I could figure out all that just by looking at this table. And I could also figure out that this is a linear relationship. Why I'm saying that? Because the rate of change is the same. The cost going up by the same 80. So I hope you guys understand that. It's a constant increase. So
Yes.
let me just try to understand this one more time. So I want a volunteer. Somebody, see if you could explain this table for me. See if you could explain the table to me. So any volunteers? Any volunteers? I'll leave him dry, so boy. Okay, I see Michael. Yeah, Michael. Try to explain it.
Yeah. So basically, the table shows the hourly rate for a job of Plaxton. And referring to the information that we found earlier, his flat inspection rate starts at $50, and for each hour that goes by, his well, you're paying him for $80 for his work added on to the inspection.
That is it. So if there's somebody that does not understand this, or they know are very patient, or they just come, ask me, and I'll go over it as much time as I need to make sure they understand. That is the mission here. So if anybody is confused by anything so far, there's a chance. Talk to me. I don't bite. I have big teeth and thing, but I don't bite. Any volunteers? I'm gonna call upon some people like in the Zoom. I see Michelle here, Akira, Cassidy. Look, Romano, look, my son. I see Lucas, Samir, Camille, Ambika. So, any one of you guys, are any of you all confused by the table? Let me know.
No, sir.
So, does everybody understand that as the time increases, you have to pay an additional 80? And so, for every hour, you have to pay, and you have to pay 80, right? I'm going to fully understand that. Okay.
Yes, sir.
Sir.
And again, if you backtrack, 130 minus 80 will be 50. And if you backtrack here, 1 minus 1 is 0. So just by looking at the table, I could see that the inspection cost might be 50 and the hourly rate is $80. So using the information provided, plot a graph of cost versus time. Not a problem. So they want us to plot cost versus time. Which one are they mentioning first? Which one are they mentioning first?
Cost.
Time. Cost. So whichever one they mention first is going to go on which axis?
The Y.
X-axis.
X.
The x-axis.
Oh, nah. Is it Y
Isn't it the
axis?
Y, sir?
Yeah. Is it Y? Physics people gonna know that. Physics people how to know that. Yeah. So
Yeah.
whichever one they mention first is going to go on the Y axis. Whichever one that they mention second is going to go on the X axis. So I see a lot of you guys may have gotten that wrong. So like, here's a quick sketch. Could somebody tell me what I'd plot over here? Could somebody tell me what I'd plot over there?
Cost.
Y.
Y.
I would plot the cost over here. Okay, and what would I plot over here on the x-axis?
Time.
So again, guys, whichever one they tell me first, which axis are gonna put on? The y-axis or the x-axis?
Y.
The y-axis. Okay, good. So let's do the question now. Let's do the question. So we recognize that we're gonna plot a graph of cost on the y-axis versus time on the x-axis. Great. So I've already prepared a graph here, and I have the information. So somebody just remind me, what going on the y-axis? What going on the y-axis?
Cost.
Right?
Cost.
And cost is being measured in dollars. Okay. What is gonna go on the x-axis?
Time.
Time.
We're measuring time in what?
Hour.
Hours.
I doing this question like how you do it for physics because I think it's double revision. So in physics, when you're writing your axes, you need to state what you are measuring as well as its units. So I have cost on the y-axis and time on the x-axis. Great. Now, here's a piece of advice I would give my students. Cost goes on the y-axis. So you see, cost here, put a y there. Length of a job, this is time, and that goes on the x-axis. So probably x above that. This is important because our point is made up of a what and a what value. Somebody tell me, what is our point made up of? A point.
X
A
and
point.
Y value.
Right. A point is made up of a x, comma, y value. So the reason I wrote an x above time and a y above cost is so that you could easily figure out your points. So is there anybody confused as to what I did so far? If you are, just tell me. I'll run over the thing. Like roadkill. Yeah, let me know if I get confused.
Yes, sir.
I feel like some people here are real confused and they're not saying anything, you know. Camille, Cassidy, Sadika, Ambika, Shania, Arlene, Rika, Nishana, Shane, Natisha. I've seen some new people here. Camellia. How much are you guys?
Sir, I understand.
Everybody understand?
Sir, I understand.
Okay, cool.
Yes, sir.
So then somebody tell me what my
So the
first
only thing
point
that
be.
caught me off guard was
Oh, sorry. Yeah, say what I was saying, Camille.
the only thing that caught me off guard was the realizing it was like a linear function thing. Well, not function, but but I was able to plot the graph properly with the x and y.
Mhm.
I did this.
Okay, well, I had to say something, right? This is a function, right? This is a function. It's a linear function. Now, for anybody in class that has a hard time recognizing,
Always tells them myself.
yeah, so if anybody here has a hard time figuring out what is a linear function, just look at the rate of change. As time changes, the cost changes by $80. It's a fixed rate of change. If it's a fixed rate of change, it's a line, it's a linear graph, it's a linear function. And here we're saying again, if the rate of change is the same, so like time and cost changing by the same amount, $80, line, 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 line. I hope all you're okay with that. So, what is my first point?
1 on your x-axis and 1 to t on your y-axis.
Right? Where's my other point? What is my other point?
2 and 210.
Right? Cool, cool, cool. Where's my other point?
3 on the X and 290 on the Y.
Okay, so I think we get the idea now. Let's try to come up with a suitable scale. So ideally, a graph should take up more than half the page. So let's start off with what's on the x-axis. We have to count from 1 to 7. So we have 16 blocks on the x-axis, and we need to go up to 7. Could anybody think of a suitable scale or not?
2 centimeters represent 1 unit.
I agree. So 1, 2, 3, 4, 5, 6. Oh no! Oh no! Nah, I don't want to write that, you know. I don't want to write that number after that 6.
7.
No. He had to say it. He had to.
All right, so 1, 2, 3, 4, 5, 6, 7, 8. Cool. Now we need to figure out a suitable scale for the y-axis. So we need to go up to 610. That's what we need to do. We need to go up to 610. So anybody has any recommendations?
So I use one mini block as 10 centimeters. So 2 blocks represent 100. That's how I did it on the y-axis.
I would advise that as well. 2 blocks is 100. Now let me explain why I'm saying that. So again, over here in this particular graph, we have 16 blocks, right? We have 16 blocks. And we need to go up to 610. So a good scale we could use is every 2 blocks is 100. Because if I do that, somebody tell me, if I do that, how much blocks am I going to occupy there? So I'm saying 2 big blocks is equal to 100. And we need to go up to 610, which is approximately 600. How much blocks would I utilize? Does anybody know how much blocks I would utilize?
12?
12? Yeah, 12 is correct. And isn't 12 more than half of 16?
Yes, sir.
So we could use that. Cool. So I'm going to label this 100. I'm going to label this 200. I didn't do a live in a long time, boy. Like, I'm low-key nervous. Like, I'm low-key, low-key. Yeah, yeah. And with all the technical difficulties and the Wi-Fi and thing, I'm low-key feeling nervous. So, like, bear with me. The vibes will come in just now, you know, the vibe will come in. But I'm low-key nervous.
No worries, sir. Me and Nikolai with you.
Okay, okay. My 2 sons with my
We,
big up
we,
for
we on the stage with you right now.
Yeah, boy. Cool.
And then Nikolai turn off the camera. Watch, watch.
Nikolai, yeah? Nikolai.
Can't do something just now.
So here what? If there's anybody confused as to the scale I used, just tell me and I'll try to explain it. So if there's anybody confused here in the Zoom, just tell me. I'll go
Excuse me.
over. Yeah, talk to me, Victoria.
I kind of confused on how you just figure out how to number the scale. I'm not sure.
Okay, no problem. So generally speaking, we should occupy more than half of the graph. So first of all, do you understand that the time is going to go on the x-axis? Let me know if you're with me.
Yeah, I understand that part.
All right, so we need to go up to 7. We need to go up to 7. Now, over here on the x-axis, we have 16 big blocks. See now?
Yes, sir.
16 big blocks. Now, I need to occupy more than half of those, half of that 16, more than half of the 16. So, if I use 2 blocks is 7, how much blocks would I occupy? If I use 2 blocks is 7, how much would I occupy? What's the end, boy? Sorry about that. Yeah, if I say 2 blocks is 1, how much would I occupy? So I say in 2 blocks is 1, and I have 16 blocks. And well, we're going up to 7. So I say in every 2 blocks is 1. So like this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7. How much big blocks did we occupy? Tell me, Victoria.
Is it 12?
Nah, not 12. So I want to go up to 7, and I say in every 2 blocks is 1. So every 1 is 2. So if I'm going up to 7 and each 2 blocks is 1, how much big blocks do you think I used? You could do it, take your time. So we're saying every
You would use 7?
nah. Okay, now I'm gonna erase the scale and let's try to understand it. Don't feel shame on thing, eh? There's a learning space, everything is fine. Okay. Yeah, so Victoria, how much big blocks do we have on the x-axis? Okay, I'll help you out, right? We have 16 big blocks. 16 big blocks. Now we need to cover at least more than half of 60. So we need to occupy the x-axis. Now the smallest value is 1 and the biggest value is what? What's the biggest value over there?
The biggest value is 7.
Right. As it is right now, if you use one big block, is 1. Is that going to occupy more than half of the graph?
No, it would not.
So what other scale do you think I could use? Think about it.
You could use 2.
Yeah, so every 2 are going to be what? Every 2 going to be what?
Every 2 will be 1.
Yeah, we could say that. Every 2 is 1. And let's quickly check that out now. So that'll be 1. This will be 2. This would be 3. This would be 4. This would be 5. This would be 6. This would be what?
7.
Did we occupy more than half of the 16 blocks?
Yeah.
Yeah, we did. So how are you feeling about that?
Okay, I understand now.
All right, that's our problem. So let's look at the y-axis now. So on the y-axis, again, how much big blocks do we have on the y-axis?
You have 8?
Well, if you count in the big blocks, it's gonna be 16. I think.
Okay.
Yeah, 16, right? 16. And now we need to go up to what? What's the biggest value on the y-axis? The biggest value.
610.
Right. We could approximately round that off to 600, right? 600 and down. 600 and
Okay.
so okay, we have 16 blocks. Yeah, 16 blocks, and we had to go up to 600. Okay. Let me think. So NG could break up 600 into divisions of 100. So like 100, 200, 300, 400, 500, 600. NG could do that.
Yeah.
Now, if I say every one block is 100, would I occupy more than half of the y-axis? So 100, 200, 300, 400, 500, 600. Did I occupy more than half the y-axis?
No.
Nah, so we think is the next move I should take. Think I should do.
You should try to.
Yeah. So every 2 is 100. So 100, 200, 300, 400, 500, 600. Doesn't that occupy at least more than half of the y-axis?
Yes, I do.
Right. So if you understand that. Nice. Nice. You good?
Yeah, I understand.
Okay, nice. So here what? My advice is break up look at the largest value, right? Look at the largest value. See how you could fit it in the graph and then probably expand the scale. So you see how 1, 2, 3, 4, 5, 6, 7. You see how that it fitted, right? But it was too small. You see that? It fit, but it was too small. I mean, if you see.
Yeah.
So the next thing you could do is potentially go to every 2 blocks is 1. So I hope you understand that.
Yeah.
So here what, guys? We need to figure out what one of these small blocks is equal to. So first of all, how much mini blocks do we have from 0 to 100? Yes, paper 2 lives. After the 7th of May, we outside every single day. Every single day we're outside 7th of May. Oliver, 7th of May. I tell you, mark down the calendar, you know. I would figure out how to use OBS something by then. I might probably upgrade the Wi-Fi. So make sure you're there 7th of May. We're going right down till the exam. We're going for like 6 hours of maths every single day or something. I don't know it's a madman. Yeah. So how much of the smallest blocks make from 0 to 100 there? Could somebody tell me that? How much small blocks making 0 to 100? Was anybody?
10, sir.
10. So if 10 small blocks, I could call that B, is equal to 100, what would one small block be equal to?
10.
10.
10.
Right? And to do that, you would have divided by 10 on both sides. So one block is 10. So in other words, this will be 10. What would this be? 10. Somebody tell me.
20.
Keep
Maybe
going.
10, 20, 30, 40,
60, 70,
50.
80,
Yeah.
90, 100. Okay, is there anybody confused as to how I figured out the divisions for the y-axis? Talk to
No,
me,
sir.
guys. Okay, happy to hear that we understand that. And well, we really don't need to figure out the divisions for the x-axis here because if you look at the values we had a plot, it's just 1, 2, 3, 4, 5, 6, 7. Oh God, why did I do that? I was unintentional.
No.
I was unintentional. But let me go now. So the first point is 1, 130. So here, when you're plotting points, you're gonna go on the x-axis and then you're going to go on the y-axis. So let me show you what I mean by that. So my first point is 1, 130. I'm going to go to 1 on my x-axis. So I'm at 1, and then I need to move up to 130 on the y-axis, following the y-axis. So this is 100 over here, and now I'm trying to go up to 130. So how much small blocks would I have to move up to reach 130? Somebody tell me that.
3.
3.
3.
Right, so this is 100, this is 110, this is 120, this is 130. So my first point would be right here. Is there anybody at all that is confused by that? If you are, don't be scared to tell me. Is there anybody confused by that?
No, sir.
All right, Romano, Nikolai, one all here. For the meeting information in the TikTok live. Yeah, I can't really do so much thing at the same time. I'll just share the thing all over the place. Share the thing all over the place. Yeah, share the thing all over the place. Right? Let's do the other point. So who wants to help me with the other point? You know what, Victoria? Victoria should help me with the other point. Yes. So Victoria, my second point is 2, 210. So what's my first step? Tell me, Victoria, what's my first step if you're trying to plot that point? Kiana here and Victoria. What about Nikki? Nikki, what's the first step in trying to plot 2, 210? Place dead boy, waiter,
Last
waiter.
time you get
So,
stick.
so first they'll go in the x-axis.
Wait, said the
go
Wi-Fi.
to 210,
Wait, said the Wi-Fi playing up. So you're saying to go by 2 on the x-axis, go by 2 on the x-axis, then what?
then 210 in the y-axis.
Right. So tell me when to stop, right? I go in, I go in, I go in, I go in, I go in. Tell me when to stop.
So it would be 1 block after 200.
Yes, sir. Big up yourself, boy, Nicky boy. Hey, big up yourself. Now we talking about. You don't know. All right. I want somebody else help me with the points. So, Victoria, see you had unmuted, but my Wi-Fi playing up. So, see if you can talk now. Try talking now.
So I'm not sure about the information. I got to decide on how you're counting it because they're making a lot of noise here.
Tell them to. I can't say what I want to say on a live. Hey, hey. anyways, yeah, Victoria. Here what I'm saying, right? You have 10 small blocks from 0 to 100. So 10 small blocks is going to give you 100, right? Let me know if you're with me, Victoria. 10 blocks is
Yeah.
100, right? And you need to figure out what one block would be. So if 10 blocks is equal to 100, you divide both sides by 10 to find for one block. So one block would be 100 over 10. What's 100 over 10? What's 100 over 10? Okay, I'm not hearing Victoria. Are they hearing me?
So it will be 10?
Yeah, it'll be 10, right? And every small block, every small increment is 10. So watch 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. You with me?
Yeah.
Okay, nice. Big up yourself. So 3, 290 now. So the first thing you had to do, you had to go to 3 on the x-axis. Let me know if you're with me there. You had to go to 3 on the x-axis because it's 3,
Yeah.
right? 3, 290. So on the x-axis, so now I need to move up to 290. That's what I need to do. So I'm gonna go, and I want you to tell me when to stop, right? So we add 3, and I'm gonna go, and tell me when to stop. Tell me when I reach 290.
I think you could stop under 300. The block
Yes,
under 300.
big up yourself, big up your whole self. That we talking about, right? I hope all you see that math's really not hard, you know. Math's really not that hard. It's really simple. So watch 3, 290. I stop one block below 300 because every small block is 10. So 300 minus 10 is 290. Okay, who wants to help me with the other point? Do I have any other volunteers? Other point. The other point would be 4, 370. Any other volunteers? Nikolai, you even need to raise your hand, boy. Look who raised their hand, Nikolai. Yeah, but Nikolai, everyone, tell me what to do.
Huh?
Tell me what to do.
So
So,
it's up with your YouTube.
so that,
First we go on the x-axis, which is 4,
right?
and then we go all the way to 370.
Tell me when to stop, right?
Mm, right there.
Yeah, righty.
So another thing to note as well, something has happened to YouTube.
Right now, my internet is really bad.
Like on this
That
front
was the problem.
on the screen.
But on YouTube, you're not saying
My internet is really, really bad at the moment. Yeah.
yeah, it's like some weird. It's like something.
Yeah, my internet is really bad at the moment. I just put it out there. It's kind of bad. So let's look at the other point. The other point is 5, 450. So I'm going to expedite the process and speed it up a bit. So it's 5, 450. We have to go to 5 on the x-axis, and I'm going to go all the way till 450. So 450 will be right here. All right, this is 450. I hope nobody is confused by that. So the point is going to be right here. Okay, somebody tell me fast. What is the next point? What is the next point? What's the next point?
6,530.
6, 530. Big up yourself. So we're gonna go to 6 on the x-axis, and then we're gonna move up to 530. So 6 is over here. I'm gonna go. I want to go up to 530. 530, that will be 3 small blocks after 500. Because again, every small block is 10. That's what we know. By the way, all this in the line that I was talking about, the money for this in the line that I was talking about,
That's
Yes,
it.
right?
Yes, sir.
Because a line has a constant rate of change, right? One thing changing with respect to the other one at a constant rate. It's a line. The last point is 7,610. This can't be a coincidence how they're playing these numbers, boy. Can't be a coincidence. I fed up see that number. Right, 7,610. So I'm gonna go to 7 on the x-axis and I'm gonna move up till 610. Okay. Okay, let me know if there's anybody that's confused as to what I did so far. Is there anybody confused as to how I plotted those points?
No, sir.
No,
Anybody?
sir.
Is there
no,
anybody
sir.
in Zoom? Anybody in Zoom that is confused? Have
No, sir.
anybody? Okay, right. All you don't know is seeing vibes. If anybody confused, let me know. I see Claire raise your hand. Yeah, Claire, talk to me. I saw Claire raise her hand. Claire, talk to me. Let me know what's going on. Claire, I'm not hearing Claire anymore. So here's what. I have all my points, so now I could just connect them to make my line.
So, what are the chances we might get like something similar to this in paper 3?
I can't tell you for sure, right? But this is something they typically bring. It's not the first time they brought a question like this. It had one where people were renting DVDs or CDs. It's the same kind of concept. So this is something that comes frequently. I wouldn't say it's something that is unusual. It could come, but
Oh,
the topics that I would recommend you guys going over: measurement and geometry, algebra and functions, statistics and data handling, relations, functions and graphs, vectors and matrices, consumer arithmetic and investigations. Hey, look, Leon Bailey, boy. The GOAT for Guyana. Yeah, big up, Leon.
Hey, big up, sir. Big up.
Yeah, boy. So let me just take my ruler, line it up with these points, and I'll draw my line. And you guys are gonna see something real cool, you know. Watch it. Are you gonna be mind blown? Watch thing. When I connect the line, could somebody tell me what the y-intercept is? Okay, wait. If you don't know what the y-intercept is essentially where the graph cuts in the y-axis. And remember, this was the y-axis. So at what value does my line cut the y-axis?
50, which is
50.
flat inspection rate.
Like I say that we're talking about. Let's see how the math's bad like that. Yeah, boy. Hey. Yeah. So at the start, when we looked at that table, we cannot call that, we cannot call that. We saw it. Let me go back to the table to show you what we're talking about. So again, the pattern here was for every hour that goes by, you have to pay 80, pay 80, pay 80. And if you went backwards, so let's just say you take away 80 from 130, you get 50, and you take away 1 from 1, that's 0. So that would have implied that at 0 hours, the cost is 50. But at 0 hours, the man didn't do no work yet, so that had to be the inspection fee. I hope you understand that. Already, maths clicking, let me know if the maths making sense.
yes.
Cool. And if I were to read off this point, what would that point look like? What would that point look like? Somebody tell me.
0.50.
0.50.
Hey, big up on yourself. 0.50. Nice. And remind me, what were we measuring on the x-axis? The x-axis. What were we measuring?
Hours.
Time. And what were we measuring on the y-axis?
Cost.
So, all you can see for yourself, right? When the time is 0, where's the cost?
50.
50.
No, if the time is 0, did the man start working as yet? If the time is 0, he do anything yet?
No.
So,
No.
No.
The man do nothing yet. You give him that 50 just for him showing his face. Right? That is what the 50 is for. The 50 is the inspection fee. Because that's a time of zero,
That's
you're paying 50. Yeah, Romano,
that's
tell me.
like that reminded me like again I one mark because you're right. This people.
Wait, say that back one more time. Again, my Wi-Fi real
Yeah.
bad. Say that back one more time. Say back one more
That's
time.
again one mark on test paper.
But this Wi-Fi real bad, boy. All I hear is one mark on a test paper. That's all I hear. All I hear was one mark on a test paper.
Yeah, good.
Gosh, but why is Wi-Fi being so
That's
far?
again one mark on a test paper for just writing, you know.
It don't work like that, Romano. It don't work like that. It don't work like that. Just because you're writing him, you're not gonna get a mark. But I wish it was the case. You know, I wish it was the case. I see Nikolai raise this hand. Nikolai, talk to me.
I don't know if this might work, but I feel that you might have to take off the YouTube because I don't think it makes sense that it be static. I think that is what messing up the internet as well.
All right, so you have anywhere on YouTube though?
It had like one person and then it came up
So how much people it have right now on YouTube?
one. I
One?
see it.
Okay.
Well, including me.
Wait.
I
All
was
right.
earlier on a
Okay, well, let me stop the YouTube and but wait, already doing it, so I guess it don't make sense because as soon as I finish with this video, it will automatically upload. So we'll continue. Fingers crossed the Wi-Fi improves over time. But I definitely had to do some work with the Wi-Fi situation. Yeah. All right. So let's move on. So is everybody okay with part one where we had to sketch the graph?
yes, sir.
Yes, sir.
Okay, nice. All right. Wait. Why everything dying? I'm thinking for why my phone dying. Bad luck, so boy. What kind of bad luck is this, boy?
It's because you said the two numbers
That is why
multiple times.
I feel
That is
as
what
it.
it is. Very bad luck.
I feel as it. All right, so I'm going live on my other phone. Okay, let me continue. So I trust that everybody is okay with plotting the graph. Nice. So now we need to figure out part two. So
That is
somebody,
terrible internet, by.
it is. Read part two for me.
So Wi-Fi becoming a reality. Um,
Yo, try taking off all the cameras. See if it will fix the problem. See if it will help a bit. Try taking off all the cameras. Okay, try talking now.
you hear me? Yes, what?
I hear you better. I hear you better for sure. For sure. Yeah. So read the question for me. Okay, I don't hear anybody, so I'll go read the question
Yes, sir.
first.
Yes, sir. I can read it. I can read it.
All right, get the
The
question already.
equation of the line represents the model to be used to calculate the cost of a job. Determine the equation of the line in the form y is equals to mx plus c.
Okay, great. Can everybody see that this is a line or no? How many people are seeing that?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So let me put down a couple of ground rules, right? What were we plotting on the y-axis? Somebody tell me that. What were we plotting on the y-axis?
What?
It was cost, yeah? And that was represented by capital C. Now, what is x? What were we plotting on the x-axis?
Time.
Time.
Yeah, and time is measured in what?
Hours.
Great.
Hours.
And C, we said earlier that C would have represented the what fee. The what fee.
Y-intercept.
Why?
Yeah, it is the y-intercept, but in this case, it also represents the what?
Cost. The cost.
Inspection fee, $50.
Yeah. That's the inspection fee. Cool. Oh, taking off all the camera real help the scene mode. Real help. And if all you had to say, what do you think M is? What do you guys think
Gradient.
M is? Yeah, M is the gradient, you know.
DET.
Yeah. That is the AT. The gradient tells us how y is changing with respect to x. The gradient is the rate of change. And when you looked at the table, you saw that the time and the cost had a difference. Okay, the rate of change there was 80. So, I mean, you don't even have to calculate the gradient because you know it's 80 from the table, but we'll calculate it anyways. So this M over here tells you the rate. It tells you the hourly rate. That's what it tells you, the hourly rate. So let's model our equation quickly. So instead of writing y, what am I going to write instead? Somebody tell me. Instead of writing y, what would I write instead? What will be plotting on the y-axis?
Cost.
Cost.
Yeah, that's going to be cost.
Cost.
What do we know the gradient is? That was the hourly rate. So what's the gradient?
80.
80.
Yeah. What are we going to write inside of x?
50?
Time.
No, not 50. Not 50.
Time.
Yeah. There we go. I'll just change this to time, right? Yeah. So we'll say 80t. And then we have to add on the y-intercept. What is the y-intercept? What is the fixed?
50.
50.
Yeah,
50.
that's 50. So does everybody understand this? I mean, I'll calculate the gradient as well, right? But let me know if you understand this.
Yes, sir.
Okay. I'll show you guys how the function works just now. But let's calculate the gradient manually. So somebody remind me. Yeah, Camille?
Oh, no, I was gonna tell you. So that's how I did it. I used 2 points on the graph to find the gradient.
That's not a
But I
problem.
did it manually,
That's not a
not knowing
problem.
like it was a function, however.
That's not a problem.
Yeah.
Yeah, so just a FYI for any of the Eagle Eye viewers, as you can see, the rate of change, right, is $80 per hour. I'm not sure if you've seen that because for us, for every hour that goes up, 80 is added. So that's how I was able to figure out that that is the gradient because that's the rate of change. Gradient is just the rate at which something is changing. So this is the gradient. That's clearly the gradient. But if you did not notice that, well, you could find the gradient manually. And to find the gradient, you would need how much points? Somebody tell me. To find the gradient, how much
2
points do
point.
you need? You need 2 points. You need 2 points to find the gradient. So the gradient is given by y2 minus y1 over what? So the gradient is change in y over
A change in y over a change in x.
correct. So y2 minus y1 over x2 minus x1. Now we are allowed to pick any 2 points that are on the graph. Any points that are on the graph. So do you all have any recommendations? And let me just try to draw this graph a bit better. Give me a moment. I'm going to draw the graph a bit better. Yeah, so I want you guys to pick some points on the graph. What's the easiest point to pick on the graph, if you all had to say?
1 and 2.
Wait, 1 and 2.
You can't use the exact points on the line, or you gotta choose something else. Isn't that right, sir?
Yeah, because what if this was a situation where it was a best fit graph? So you can't pick the points that you were given. You need to read off points from the graph. So the easiest point that I am seeing here on the graph is the y-intercept. That's a very easy point to pick. I'm not sure if you guys seeing that. This is a very, very easy point to work with. So I'm going to use this point. So I'm going to use 0, 50. So that's 1 point I could use, 0, 50. And so now we need to pick another point that is on the graph. So we need to read off a point. Are you guys seeing any nice points that I could easily read off? Let me know.
2, 2 and 210.
Wait, here what I was saying, right? You cannot use the points that were given to you. When you draw a graph, you need to pick points from the graph. So other than the points that we use, try to use some other points. Try to read off some other points from the graph. So I want
5.5 and 490, sir.
say that again.
5.5
So what about
and 490.
what about 8 and 700?
Okay, 8 and 700, that wouldn't be quite right, because when the time is 8 is not exactly at 700. So that wouldn't be exactly 8, 700. But you know what it would be?
Yeah, 8 and 6.
8 and 6 what?
Like 690.
Yes, 8 and 690. So here what Akira, that's a completely valid point. But I see in some easier points, there's some easier points there on the graph. There's an easier point on the graph.
2.5 and 250.
So I use
Yes.
7 and 610 and 5 and 450.
Now here what I'm saying, Camille, you typically can't use the points that are given to you. You need to draw a graph and then take points from the graph.
Well, that's the two easy points that I saw when I drew the graph.
Wait, it sounds like
So that's why I went with them.
you use these points that were given.
Yeah.
Now, when you draw a graph, you have to pick points from the graph to do your gradients, typically. So an easy point that I'm seeing
Take
from the
points
graph.
off of this graph here, right?
Yeah. So this point would be
Yeah, that's what I did.
2.5. 250. Let me know if you guys understand that. 2.5, 250.
Yes, sir.
Yes, sir.
So that's an easy point to use. So I could use 0, 50, and I could use 2.5, 250. So let me work with it. So here they say it really doesn't matter which one you call the first point or which one you call the second point. Either way is fine. But we need to pick one. So what do you guys want to call the first point?
A and B. We could call it A and B.
Yeah,
X1 or Y1, sir.
you could call the points A and B, but it doesn't matter. We just need to label it. So here what? We could call this the first point. Again, it doesn't matter. It'll work out anyways. So we could call this one x1, y1. Yeah. And we could call this one x2, y2. Let me know if you guys okay with that. It really doesn't
Yes,
matter. It doesn't matter. I could have, as I'll show you guys, it doesn't matter. I'll switch it around and you'll see you get the same answer. Does not matter. And let me just clarify this. The points I am picking from the graph, it had to be on the line. If it's not on the line, then it doesn't obey the function. It needs to be on the line. So I just pointed that out there. Right, notice the points I picked were on the line. You need to pick points that are on the line. And you can't pick any of the points that were there already. You need to draw a graph and pick points from the graph. So let's quickly find the gradient. So the gradient here is going to be y2 minus y1. y2 is 250. Y1 is 50. And that's going to be over x2 minus x1. So x2 is 2.5. And what is x1? x1 is 0. So what is 250 minus 50? Somebody tell me. 250 minus 50 is what?
200.
Yeah, that's 200. So 200 over
2.5.
2.5.
Yeah, where's 200 over 2.5?
80.
Yeah? Let me know if you guys get the 80.
yes, sir.
Yes.
Yes,
Okay.
sir.
Now, let me prove a point here because some students, they just be like so confused when I tell them the order doesn't matter. So let me just prove that point here. Because it's important for coordinate geometry. It's really important that you know that the order doesn't matter. So here what? What if I call that x1, y1 and I call this x2, y2 instead? We're still going to get the same answer. I promise you. So again, gradient is y2 minus y1 all over x2 minus x1. What is y2? Somebody tell me. What is y2? What's y2?
50.
What's y1?
2.5.
Right? What's x2?
0.
What is x1?
2.5.
So when you work out the top 50 minus 250, that's going to be minus 200. And 0 minus 2.5, that's going to be minus 2.5. First of all, what is a negative divided by a negative?
Positive.
A
Positive.
positive. That is what a negative divided by a negative is, right? So, we get a positive number. Cool. And well, 200 over 2.5 gives us back the 80. Let me know if you're okay with that.
Yes, sir.
Yes, sir.
Good. So
Yes, sir.
let me just do a quick recap. When you need to find ingredients for a line, you typically draw your graph, then you read off points from your graph. Now, I'm doing this because it's very important for physics. Anybody here doing physics? Let me know. Anybody here do physics?
Yes, sir.
Okay.
Okay. When I draw a graph for physics, right? And it would have some points that kind of doesn't fit the pattern that you notice. It kind of
Yes,
like
sir.
Yes.
you go have points like this, right? And then you go have 1 point out there, right? You might have 1 point off there. So these might have been caused due to some error in the experiment. So what you need to do is you would first draw a best fit. You draw a best fit, and after the best fit, then you'd be able to actually take points from your graph. So I want to apply the same concept here in maths. You draw your line. After you draw the line, read off 2 points that are on the line. So I drew my line and I read off 2 points that were on the line. I'm not going to use any points that were given to me. I'm going to try to use points from the graph. I'm going to try to read off points from the graph. So that's general rule of thumb. Let me know if you guys understand that. So for a line, you're going to draw your graph. Then you're going to take 2 points on the line, has to be on the line, and you find the gradients. Are they okay with that? Yes or no? Let me know if you guys okay with
Yes,
that.
sir.
Okay, good.
Yes,
Question.
sir.
If I wanted to find gradients, could I pick a point here and a point here? Yeah or no? That legal?
No.
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 Not illegal.
What about over here and over here? That legal or that illegal?
Illegal.
Illegal.
That's illegal. Right? What about here and here? That legal?
Yes, sir.
Sir.
Yeah.
Yes, sir.
Because it's on the line, it follows the relationship. Now, I want to make something abundantly clear because some of you guys would find this and you would have no idea what this means. You'll have no idea what that means. I know that. How much of you guys here, you find this, but you have no idea what I mean? Tell me. A lot of students do that and they don't know what you mean. So somebody tell me. Let me know if they're confused. Do you know what it stands for?
Yes,
Yes,
sir.
sir.
Okay, well, I'm gonna assume that all you do understand, and I'm gonna show you something really cool. This is a function, there's a function. A function is something that takes in an input, it will do something to the number and give you an output. So this function relates what to what? Somebody tell me. What do you think this function relates? It relates what two things? Nikki, see if you can tell me, what does this function relate? What two things?
So the inspection fee. No, this one is the hourly rate and the inspection fee.
You're not wrong. But I'm looking for something in terms of the variable. So like, remind me, what does the C stand for? What does the C stand for? The C,
Cost.
right? So we have an equation here that is telling us what the cost would be in terms of what? What's the variable there? What's the variable there?
This would be X and Y.
Now,
Or
okay,
Y and X.
let me take a little step back,
No,
right?
sir, I don't understand. Some MX plus C.
Right. So okay, I'll go over the whole concept, right? So a line would always be uniform y is equal to mx plus c. Now, Nikki, for our graph, what did we have on the y-axis? We had cost. On the x-axis, what did we have? We had time. So instead of writing y, I wrote c because that is what I had on the y-axis. I had cost. I'm gonna do it, Nikki.
Yes, sir.
And for the x-axis, I had time. So that's why instead of y, you saw me wrote cost. And instead of x, you saw me wrote time. So this function here, it tells you how the cost is linked to the what? It tells you how the cost is linked to the
Time.
yes. And you're probably saying, sir, I don't believe you, no. I don't believe you. Let me show you some proof. So, Nikki, from the graph itself, when the time was 2 hours, where's the cost? So, like, I way to zone in on this example here. This is a little example so you will understand what happening. When the time is 2, where's the cost?
$210.
So earlier, if I use the function I came up with, shouldn't it give me the cost when t is 2?
Yes, sir.
Yes,
It
sir.
should. It should. So from the table, we see when the time is 2, the cost is 210. Let's check to see if that's true. So Nikki, we want to verify that when time is 2, the cost will be what? We're trying to verify here.
When the time is 2, the cost would be $210.
Let's see now. So 80, I'm going to plug in 2 into the function. So 80 by 2 plus 5. Where's 80 by 2?
160.
Where's 160 plus 5? 50. Where's 160 plus 50?
Just
And actually, well, let's see it, you know. Well, let's see what this function is doing.
Yes, sir.
Yeah. It tells us how the cost is linked to the time. So, Nikki, where's 160 plus 50?
so 210.
Right, 210. So, was our function faithful to the actual values in the table?
Yes, sir.
Right, because, Nikki, from the table, when time is 2, what the cost supposed to be?
$210.
I wanna plug that into the function we came up with. Did it give me back the 210?
Yes, sir.
And this will work for any value of time. Granted, is more than or equal to 0, right? Because you can't have negative time. Time is a scalar quantity. Physics people gonna know that. You know what? I know I have some trust. I know I have trust issues, so let me try it for another one. Here what? I want to try it for any other values in the table.
So try 5.
Try 5 and 450.
Yes, sir.
So Nikki, according to that, right? When the person would have worked for 5 hours, you'd have to pay them how much money?
$450.
Let me see if let me see if we function faithful to that now. So we want to figure out the cost when the time is what was again? I have the memory of a goldfish. T is equal to 5. So Nikki, what would I put into the function then to find the cost?
So it would be 80 multiplied by 5.
Yeah, plus 50. What is 80 by 5 plus 50? Somebody tell me what is 80 by 5 plus 50? What is that?
450.
450.
Yeah, Nikki, let me know if you get any 450. 80 by 5 is 400, 400 plus 50 is 450.
Yes, sir.
And isn't that what was said in the table?
Yes, sir.
Right. So, does everybody understand that we came up with a function relating the cost to the time? That's what we did.
Yes, sir.
Again, if I come to math vibes, the point of my channel and thing is really to develop a deeper thinking for maths. I don't just want it to memorize this, learn that, and get. No. We thinking deeper than that. We better than that, you know? I am stronger. I'm better. I don't know if you know that meme. Or like I'm too old. Or you know that meme?
Yeah, I know it.
Yeah. Okay, cool. So I hope everybody okay with this. So we just came up with a function linking cost to time. So I want somebody to help me with part 3. And we know the answer part 3, right? What's the answer for part 3? The inspection cost. What's the inspection cost?
$50.
Right. So the inspection cost is $50. And if there was anybody here that didn't understand that, fear not, I'll go it over quickly. So inspection cost. Somebody talk to me, right? This is common sense. This is pure logic. When we're talking about inspection cost, did the person do any work yet? Did the person do any work yet?
No, sir.
No. People on TikTok, an inspection fee. Did the person do any work yet? If it's an inspection fee, did they do any work yet? It's an inspection fee. Somebody give me a guess. If it's an inspection fee, the person started work yet?
No,
Okay,
sir.
people on TikTok kind of dry, but the answer is no. Typically, you would ask somebody to come over, check the machine or something. They would charge a cost, and then they would start to work on it. So in other words, the inspection cost will be the cost you have to pay when the time is what? When the time is what?
0.
Exactly, when the time is 0 hours. That's like a fixed fee you had to pay. Yeah. Are they sure they understand that or no? I feel like they do fully understand that.
I don't know. I understand, sir.
I
But I don't know
understand.
about the rest of them.
One more time, please.
I understand.
Sarah, you see, I like Sarah. Big up yourself, Sarah. I'm happy that you could admit you want me to go it over again. That's good. That's a sign of learning. So, Sarah, inspection. If the person comes to do inspection, did they start working on it as yet? Did they start working on the machine or something as yet?
No.
No. So, the time would be what? If they didn't start working as yet, what's the time?
0.
Exactly, the time is 0. And when the time is 0, here what, Sarah? And ideally, when the time is 0, you shouldn't have to pay a fee.
No.
No, because he didn't do anything yet, right? But you're seeing here from the graph that when the time is 0, the cost is 50. You're seeing that, right? When the time is 0, the cost is 50. So did he do any work as yet?
No.
But he's still getting money. Yeah?
Yeah.
So
Okay.
what that had to be then? What that have to be then? That had to be representative of the what? That 50, what is
Sorry,
that?
sir?
So
There's the fee they have to pay.
yes, yes, yes. So that's what he has to pay. That's the inspection cost. Let me know if you understand that.
Yes.
One more time. So the inspection cost is the amount that you have to pay regardless of if you do any workers yet. So he didn't do any workers yet, you know. So the time is 0. But you still had to pay some money because he had to inspect, he had to do some inspection first, and then he would start to work. So from the graph, you're looking at the y-intercept. When the time is 0, you notice that you still had to pay some money. You had to pay $50, implying that that is the inspection fee. That's the fee you had to pay at the start before he do any work on the device. Well, I don't know. What is do again, boy? I forget what this man is doing now. Plaxton. He owns a plumbing company. Okay, a plumbing company. So he had to come and inspect the plumbing before he do any work. So that's time 0. He didn't do any work as yet, but you still had to pay that 50 because he had to come and inspect the place. Everybody feel like they understand that or no?
Yes, sir.
Okay, bet. All right. I want somebody to help me with part B. So they're saying Plaxton received $490 for our job. How much money he get?
490.
Hey, look, Bali dog. Bali look the goats. They got Bali one time. Yeah, so Plaxton received $490 for our job. So that implies that he would have charged how much? And $490?
Yes, sir.
Yeah, so this would have been the cost of the job, would it not?
Yes, sir.
That's the cost. And they want, I don't know why the man name is Plaxton, and best they could have just put Plankton and done. Determine the number of hours he spent on this job. So they're giving us the cost and they're asking us to find what? What are they asking us to find for?
The hours he
Time.
spent on
The
the job.
hours you spent.
Right. So they are giving us cost and they're asking us to figure out the time he spent on the job. So is there a formula we came up with that relates cost to the time?
Yes, sir.
Yes,
Yes.
sir.
Yeah. We know that the cost is equal to AT by T plus 50. So if I wanted to figure out the time, then I would just have to plug in the what? What I have to plug in?
The cost.
The cost.
Nikki, let me know if you're seeing that. The cost. Wasn't the cost
Yes.
given to us?
Yes.
Yeah, the cost was given to us. So we are going to say 490, and that's going to be equal to 80T plus 50. Now, when you look at this, how much unknowns are seeing there? How much unknowns are you guys seeing?
1. The
One.
time.
Right, and you could only solve one equation if it have one unknown. If you have two unknowns, you would need two equations because you know simultaneous equations. Yeah. But generally speaking, we want to end up with an equation with how much unknowns? How much unknowns we want?
One,
One.
sir.
One is the ideal thing. And that goes for beyond maths, yeah? One is enough. I'll go put context to that. One is enough. More than one is headache. Not that I have any experience with more than one, but like I just see,
Right.
I only had one. Like I have my girlfriend since from 5, 6 years. I happy. You know, just one. She looking at this.
Oh,
Yeah. I've never known anything but one. One is enough. Two
So I had
problems.
my cap calculator since primary school. I just saying.
Hey boy, that's
Oh,
a
and
sharp
so
sharp you.
yeah, you have one real son and one adopted son.
Yeah, boy. All the people on TikTok, right? So you see this man Romano, that's my son, right? Wait, no, what I'm saying. Romano is my adopted son. He's my adopted son. But my real son is really Nikolai, you know. My real son is Nikolai. Yeah. That is the law to behind math vibes. And that's a little law. If you didn't know. So let's solve for t. So we have 490 is equal to 80t plus 50. We are trying to find for t. So we need to isolate t. When you look at the right hand side, is t the only thing there?
No, sir.
No,
No.
sir.
No. Now here what a mistake some students would make is they would try to minus 80 and all kind of thing. No, you can't do that. You cannot do that. You cannot minus 80 because the 80 is telling you how much, it's telling you where you're multiplying time by. So 80 by t, 80 by t. You can't minus 80. You could probably divide by 80, but you can't minus 80. You can only do the opposite operation. Right. So we see now we have a 50 on the right hand side. So we need to get rid of that 50. So how can I get rid of that 50? Somebody tell me.
You would
Minus it.
cross the
Calculate from 490.
Yeah, I'd move it across. Now, a way to think about it as well is I could take away 50 on both sides because 50 minus 50, that would eliminate it. So think of it like this. You move it across, change the sign, or you do the opposite operation on both sides. So you take away 50 on both sides, or you move it across and change the sign. Both is fine. So you're going to end up with 490 minus 50, and that's going to be equal to what?
440.
That would be 80t,
What is 490 minus 50?
440.
440.
So we have 440 is equal to 80t. So we have 80 being multiplied by t, and we're trying to find for t. So what is the opposite of multiplying by 80?
Divided by 80.
Right. So we need to divide both sides by 80 if we want to get rid of it. So you see that the 80 and 80 cancel off. So now we could find for t. So somebody tell me, what would t be equal to? What would t be equal to?
5.5 hours.
5.5, sir.
Nice, 5.5 hours. Everybody okay with that?
Yes, sir.
yes, sir.
Okay. Now I'm gonna say it in big. That wasn't the only way you could have worked that question. You could have also used graph. And this is prime time to blow all their minds. So if we were to use the graph, right? The first thing we're seeing is the course is 490. We're seeing that. So I'm going to go to my graph and I'm going to go on the y-axis. So 490, where's 490? Could everybody agree that 490 is over here?
Yes, sir.
Yes, sir.
Let me know if all you're seeing that as 490 over there. Yeah, no, maybe potentially.
Yes, sir.
Yes,
Yes.
Right? And then, okay, so you see the 490, it cuts the graph at this point. So then you take a vertical read off to see what the time would have been. What does the time look like it is? Somebody tell me.
5.5.
That is why you're saying, unless you know the mathsing.
Yes.
Sir, I just check probability like that.
Probability like that. Okay, what? After class, you go tell me what you mean by that. I might be
Yeah,
concerned
but
or I
I
might be
cannot.
impressed. But you had to tell me what you mean by that.
Might be concerned it's crazy.
I might be concerned or I might be impressed. We don't know. But let me wrap up everything now. So over here, we have a graphical representation. But you could represent this on pen and paper with this equation we came up with this function, right? So you see that c is equal to 80t plus 50. That encompasses the whole graph with just this one line. So a function tells you the graph in like one line. So I'll probably understand that. It's pretty cool, right? So you see, when I plugged in 490 into the function, so I plug in 490 for C, and I made T the subject of the formula, I got T to be 5.5 hours. That's why I got T to be. And when I read it off from the graph, so I went at 490, I took a read off, I also got 5.5. So that was really cool. And here what? If you are having trust issues, let me show you what you could do, right? So in maths, What is an equation? Somebody tell me fast. What is an equation? What is an equation? What does that mean? An equation.
Something equal to
One side had to be equal to the
a
what?
number.
Not
To the
quite.
other side, so
So like in maths, an equation just simply means the left-hand side had to be equal to the right-hand side. That's what it means. Now in the question, what did it tell us the cost was? What was the cost?
490.
490.
Okay, and what do we find time to be?
5.5.
So if I plug
5.5.
it back into the function, what's supposed to get? When I multiply this out, what's supposed to get?
The same thing on the left hand side, which is 450.
490. If we correct. If we are
All right.
correct. So what is 80 by 5.5? Somebody tell me. 80 by 5.5. What's that? 80 by 5.5.
440.
440.
440. Oh, hey, earlier. Where's 440 plus 50? Where's 440 plus 50?
490.
490.
Right. So you see? Makes sense, right?
Yes, sir.
So most things in maths could be checked back by simply plugging it back into the equation. Because in maths, you're trying to solve for the variable or the unknown that would make the equation satisfied. So left hand side equal to right hand side. Are you okay? Or not?
Yes, sir.
Yes, sir.
And this is some proof. Okay. So this is the calculation method. This is the calculation method. And well, obviously you had the graph here. This is the graph method. This is the graph method. Boom. So after we're done with the paper, we'll run through the whole thing just to make sure everybody's fully like on the same level. Like something about me, if you go on my YouTube, the videos be long for a reason because I have like OCD. I cannot move on if I know a student is confused. Everybody had to understand. Otherwise, we can't move on. Right? Everybody had to understand. Check other page. Bets. So is everybody okay with the first question, with how we plot the graph, how we found the equation, how we got the inspection cost, and how we figured out the time? I'm gonna follow you okay with
Yes.
this.
Yes, sir.
Okay, good. Right. So somebody get us a read from her. Give it a read. Why the man named Blackstone, buddy?
I don't know.
Yeah. Yeah, but somebody give us a read. We're wasting time. Somebody lock in.
Claxton and Leela
Wait,
are
wait.
now working jointly.
Well, every time I ask her, let's read that question, and I'll taking a little while. This is how I just feel on the inside. Like literally, I just feel like this on the inside. It's kind of nerve-wracking. I don't know if anybody got an answer, but yeah. Continue, Sarah.
Yeah. So if nobody
Claxton
was
and
going to do it,
Leela
I'd do it, sir.
What's that again?
I said if no one was going to do it, I would have read it.
Yeah, well, Nikolai is my son. Of course you go answer. Of course you go answer, right? But yeah, Sarah, go.
Lifestyle and Lila are now working jointly and they must settle on a common model to be used to calculate the cost of a job. Lila charges $50 for inspections and $90 per hour to do a job, but unlike Flaxman, she refunds the inspection cost to the customer once the job is given to her. Flaxman wants to compare the two models. Using some pair of axes on page 5 of the answer booklet, draw the line representing Lila's model, assuming that she is given all the jobs that she inspects.
Wait, boy, Sarah, that look like a English problem, eh? How long it is? You know, like
It just looks like a paragraph to many people to figure it out.
okay. Let me show you something, right? In a higher level of maths. Okay, let me show you something, right? Let me show you something. You see that paragraph? That paragraph looking like a whole essay for me, right? Because like when you're doing higher level maths, this is the question. That's the question. There's no talk about numbers and thing. There's no talk about numbers and thing. I mean letters. Like you see how is that whole paragraph? In higher level maths, it'll be like that. Like Yeah, so
Yeah, I hope you're right. I
I
really hope
find
you're right because I do keep soon.
what's that again?
I hope you're right because I do in Cape soon too. So I hope I don't see these word problems come up for me again.
You'll see it less to a lesser degree, but you'll still see it. You'll still see it, but to a lesser degree. Don't worry.
Excuse me, sir. This question has been paper two for CXC.
Here, watch, right? I want everybody on TikTok and YouTube, everybody watching, right? All yeah, maths is maths, eh? Maths is maths. Everything we do in paper three could come in paper two. Vice versa. Everything is maths. Everything is maths. Maths is maths. So what we're learning here is an application of coordinate geometry right now. That's what we're learning right now. This is coordinate geometry. And lines, functions, and graphs. This is our application. So yeah, things like this will come in paper two. So let me actually understand the question, right, Sarah? So we have a new person here, right, Leela? Now, Leela has a different way of working. She would charge $50 for the inspection, right? And she has an hourly rate of $90 per hour. So, Sarah, who has a higher hourly rate? Who has a higher hourly rate? Was it here? What's it? One of you guys send the meeting information on the TikTok so people could join the TikTok. I mean, what's saying? People could join the Zoom. Somebody send the information on the Zoom, right? So
Yes,
the
sir.
people on Zoom could join. I mean, oh my God. So the people could TikTok could join. People on TikTok. One of my students go and send the link for the Zoom. I'll go join it, right? Now YouTube very unreliable. So Sarah, who has a higher hourly rate? Is it Leela or is it Plaxton?
Leela,
Yeah, she has a higher hourly rate, but there's a catch. There's a catch. Unlike Plaxton, what does she do?
she refunds the inspection cost to the customer once the job is given to us. So they don't have to pay, unlike if they have taxes, they would still have to pay.
Correct. So once you so like she would charge you an inspection fee, right? But if you accept the job, you don't have to pay it. Are you understand that? Let me know if you understand that.
Yeah.
People in the class, does everybody understand that if you ask her to do her job, right, she'll do some inspection. If you tell she you don't want the job done, you have to pay 90. But if you tell she you want the job done, you would not have to pay the inspection fee. I'm sorry, I say 90. You wouldn't have to pay the 50 for inspection. I'll run it back one more time. So Nikki, they're saying Leela charges 50 for an inspection and $90 per hour. But if you ask she to do the job, she will refund you the inspection cost. So Nikki, if you're rolling with Leela, right? If you're rolling with Leela, do you have to pay an inspection fee if you accept the job?
Yes, you do. You have
Nah.
to pay an inspection fee, but
Wait, eh?
so
Nah.
and then afterwards she will.
What are you doing?
Yeah, afterwards. Afterwards. So once you accept the job, once you give her the job, she won't charge an inspection fee. She'll give you back the money. She'll give you back the money.
Okay.
So let me explain, right? Let me just say that this is you over here, right? Wait, eh? And well, this is Leela over here. And you say, hey, I have work for you. And she's like, bet, right? She tell you the inspection work was 50, and I have an hourly rate of 90, right? So Nikki, let me just say a call she, right? You call she, right? You have this pipe to fix. Say call she, right? Right, Nikki? And you say, and
Yes.
you tell she to inspect the pipe for you. She say, okay, no problem. You know that inspection fee go be 50. And
Yes, sir.
after she inspected, you say, nah, I don't want you to fix it. You say, nah. What would that mean?
You still have to pay the dollars.
Exactly. If you
Yes,
tell
you
she,
would still have.
say it, yes, say what I was gonna say.
Well, if you tell her, well, to go ahead and fix it, you would have to pay the 90 plus the 50.
Nah. If you tell her to fix it,
Not
if you give her the job, she's going to refund you the inspection fee. So you'll just have to pay the 90 per hour.
50,
That's what they're saying over here.
90.
Unlike Plaxton, she refunds the inspection fee to the customer once the job is given to her. So if you give her the job, she'll give you back the 50. But if you just tell her no, you have to pay the inspection fee. You understand? Okay, I feel like you don't understand now. Let me run it back again.
No, sir, I understand it. I understand it now.
All right, so Nikki, let me just say you as Lila, right? I say, all right, Nikki, I have a job for you. Come inspect the pipe here. How much you gonna charge, man?
$50.
I say, Nikki, no, I don't like your vibes. I don't like your vibes. And I'm not letting you go and fix the pipe. I'll call somebody else. How much I'll pay you?
Still $50.
Still 50 because I didn't let
Yeah,
you
but
do the job. I didn't let you do the job, right?
yeah,
But if I say, Nikki, I like your vibes, I like where you're moving, you know, you look like you know your thing. Come, do the job. What happened there?
you would have to pay $90 because the $50 would be refunded.
Exactly. So the
So
50
it
will be
would be
responded.
$90 in
Right. So
total.
every hour that goes by, you'd have to pay her 90. But she would give you back the $50. Sarah. Sarah, do you
Yes.
understand that? Sarah, let me know if you understand that. Let me know if you understand.
Yes, sir.
So I'm gonna go into her one more time for anybody that potentially might be confused. So if you tell her to do the job, all you had to do is just pay $90 per hour and she'll give you back the 50. But if you call her and you tell her to inspect a pipe and you don't give her the job, you had to pay the 50. And you had to pay the 50. But if you give her the job, you don't have to pay her the 50. She's gonna give you it back. And you'll just have to charge her for the hour. Everybody here, do you all understand? Are you sure you understand?
Yes, sir.
Yes, sir.
Okay,
Yes,
good. So using the same pair of axes, on page 5, draw the line representing Leela's model. This is very important, assuming that she is given all the jobs that she inspects. So Sarah, this is very important. It says assuming that she is given all the jobs that she inspects. If she is given all the jobs, you just had to pay $90 per hour, right? Let me know if you understand that.
Yes, sir.
Yes, sir.
All right. So let's come up with an
Yes,
equation
sir.
to represent her model. So the cost would be equal to what? See if I can figure it out. Now she getting all the jobs, you know. So you don't have to pay an inspection fee. So what would the formula
So
linking cost and time to be? What would it be?
what will be cost equal 90T
That is it. That is it.
plus
Nah, no plus, no plus, no plus, no
uh,
plus. Could somebody tell me why I'm not going to add on the inspection fee? Could somebody tell me why I would not add it on?
Because it is
Job.
refunded.
Wait, I hear multiple people. Nikki, tell me what you said again.
Because it is refunded.
Why is refunded though? Why refunded?
So because the $50 is refunded
Nah,
because she took the job. Once she took the job, the $50 would be refunded.
that is what I want to hear.
Inspection fee.
Right. That is what I want to hear. If you guys read this, you'll see that assuming that she's given all the jobs. So Victoria, do you understand that once she's given a job, you essentially don't have to pay her inspection fee? Just the hourly rate? Victoria, let me know if you understand that.
Yeah,
Okay.
understand that part.
Are they hearing more? No. Let me know if are they hearing more? No. Okay, so let's explain this function quickly. So Nikolai, do you understand that for every hour that you work, for every hour that she works, you'll have to pay $90? Yes or no? Because that's the hourly rate.
yes, sir.
Okay, so if she worked 1 hour, how much would you have to pay her? Somebody tell me. According to the question, how much you'd have to pay her?
$90.
$90.
$90.
If she worked for 2 hours, how much would you have to pay her?
180.
180.
If she worked 3 hours, how much should I have to pay her? 270. So does everybody understand how I came up with this function over here? Saying that the cost would be 90 times the time?
Yes, sir.
Okay. So we need to plot our graph now.
Yes.
So again, what we plotting? Now on the graph, we were plotting cost versus time. So cost versus time. So the cost was the y-axis and the time was the x-axis. So according to her rates, right? According to her rates, let's come up with a couple points because to draw a graph, you need some points. So when the time is 1 hour, remind me, where's the cost? Where's the cost? When the time is 1 hour.
90.
90.
When the time,
Yes.
if she worked for 2 hours, how much had to pay her?
180.
$180.
Right? How much points you need to draw a line? Somebody tell me, how much points do you need to draw a line?
2.
2.
You only need 2 points, so you don't have to do anything again. You only need 2 points, but let's just do 3 to be on the safe side. If she works for 3 hours, how much should you have to pay her?
270.
Right. So
270.
let's write this as points, right? So the first point would be 1 comma what? What would the first point be?
190.
Yeah, 1 comma 90. What would the other point be?
180.
Hey, big up the dog Keen. Big up Keen Serit Maths. I'll go check him out. He real good too. He real good too. I recommend him. Yeah, so 190 to 180. And what would the other point be? The other point.
3.
270.
Right, 3 comma 270. So I really, really hope nobody is lost. Again, if you're confused, they said assuming that she is given all jobs that she inspects. If Leela is given a job, she's not going to charge you for the inspection fee. She's just going to charge you per hour. And her hourly rate is 90. So that is why I said if she worked 1 hour, you'd have to pay her 90. If she worked 2 hours, you'd have to pay her 180. If she worked 3 hours, you'd have to pay her 270. So her model could be represented by C is equal to 90T if she gets the job. Does everybody
So how
understand?
much time how do we know how much time she work for though?
You don't, but we're creating a graph to kind of to see the cost at any given time. That's what we're trying to do. So
Oh, okay.
because Victoria, we don't know how much time she's working for, but if we could come up with a straight line or a function, we could figure out what the cost would be at any given time. I'm not sure if you understand what I mean, but so let me show you.
Oh, yeah. Yeah, I understand.
If we know she getting $90 per hour, right? If she worked for 5 hours, what would the cost be? What do you have to pay her?
It would be
90
90
times
multiplied by 5.
Exactly 90 by 5. 90 by 5 and 90 by 5 is 450. So, Victoria, we don't know how much time she's working for, but we are just coming up with a line or a function that models her rates and how you pay her. Let me know if you understand.
Okay. Yeah, I understand.
Now, again, Victoria, we know that this is also going to be a line because it's a fixed hourly rate. Once it's a fixed change, it is a line. It will look like a line. It'll be a line. So to draw a line, you just need 2 points. In part 1, they asked us to draw the line representing Leela's model. So what did I do? I came up with some points. So when time is 1, you had to pay her 90. When time is 2, you had to pay her 180. When time is 3, you had to pay her 270. Really, you only need 2 points because if you have 2 points, you can connect them to draw a line. However, I choose 3 points just for safekeeping. All right. So let's go on the graph and plot these points. Let's do that. And again, if anybody is confused or they don't know how it is moved, I will not move on if you're confused. So just ask me. I really don't want anybody to be confused. Let's put on the first point. So I'm going to use a different color to represent Leela's model. So that's gonna be 1 comma 90. So 1 comma 90. So Victoria, if it's 1 comma 90, I'm going to go 1 unit on the x-axis, and then I'm going to move 90 up because it's 1 comma 90. Remember, every small block is 10 units. So one block less than 100 would be 90. So let me run it through one more time. You're going to move 1 to your right, then you're going to move up till you reach 90. So my point is going to be over here. Talk to me. Like, do you understand that? Do you understand that, Victoria?
Yeah, it could be 1 point under 100, yeah.
Right? And then we have 2 comma 180. So 2 comma 180, we're going to go by 2, and then we're going to move up till we reach 180. So 180 would be over here. Okay. Right? Then we have 3 comma 270. Right? 3 comma 270. So that would be right here. Okay. So guys, if we have 3 points, could you take a ruler and align it and draw a line? Yes or no? If you had those 3 points.
Yes.
Yes. All you confused or all you understand? If you're all confused, right? So Cassidy, how much points do you really need to plot to draw a line? Tell me, Cassidy, how much points do you really need to draw a line? How much points you need to see to draw a line?
2.
You just need 2
Sir.
points. We do 3 just to be
2.
safe, right? So here what I'm gonna do, I'm gonna take my ruler, I'm gonna line it up here. And I'm gonna draw my line. And A, all you should already be thinking about points of intersection, eh? Anytime you draw 2 graphs, points of intersection should come to mind. One time. One time. Right. Let me know if you're with me. So I draw a line there. Are you okay with that? Let me know if you guys
Yes,
okay
sir.
with that. All right. Nice. Now something I want to point out. When I drew this line, notice that it cut at 0. It cut the y-axis at 0. Could anybody explain why that makes sense? Could anybody explain why that makes sense? Why does it make sense if it cuts the, why does it make sense that it cuts the graph at 0? Why does that make sense? Somebody tell me. Could anybody tell me? It has to do with the inspection fee.
So because the inspection fee is 0, it is refunded.
Nikki, give me a high five there, boy. Big up yourself. In the question, they said that when she gets the job, you don't have to pay the inspection fee. So that's why when I draw the graph, you see that the inspection fee gonna be 0. Because she get any job, so you don't have to pay her inspection fee. I really, really hope we understand. I really hope we understand. Yeah? Cool. So I would have just answered this question. So using the same pair of axes, draw the line representing Lila's model. Does everybody understand how I did that? Yes or no?
Yeah. Yes, sir.
Yes, sir.
Okay, that's good to hear. Right, part 2. Determine how long a job that returns the same cost for both Flaxton's model and Lila's model would take.
Excuse me, sir.
Yeah, Camille?
Can you scroll up a bit, please?
No problem.
You could just scroll up a bit. Where C is equal to 90. That part, sorry.
Over here.
Not on the graph itself, on the question. Yeah, here.
Excuse me, sir. Excuse me, sir.
Wait, sir. Let me just
Could you go?
address Camille quickly. So Camille, you want me to go over the C is equal to 90 part, 90t part?
No.
Sir, could you repeat, sir?
Wait, sir. My internet kind of bad. and there's a slight delay. So wait, Danielle, Camille, wait, what do you want me to go over?
Sir, like, I don't understand why we're plotting. I joined late. Sorry.
Okay, no problem. I'll explain that just now. But Camille, I want to know what is confusing Camille. Camille, I want to know what's going on. I want to know what's going
No, not, well, it was clarified, but it wasn't confusing or anything. I just didn't understand the question properly or answer properly, more or less.
I understand. The question wanted us, so they gave us information for another person, Leela, and she has a different way of charging people. So they wanted us to plot a graph of Leela's model, like how she charges people. And that's what we did. And to do that, we came up with some points. Now, if you give her the job, you don't have to pay an inspection fee. All you have to do is pay $90 per hour. So, like, if you give her the job, well, if 1 hour pass, you have to pay her 90. If 2 hours pass, you have to pay her 180. If 3 hours pass, you have to pay her 270. And that could be modeled by this relationship over here, where T is time. So so like as you can see, if she works for 1 hour, 90 by 1 is 90. If she works for 3 hours, 90 by 3 is 270. So Camille, let me know if you understand. So that's how I came up with the relationship, and I would
Yeah.
have figured out some points, and I would have plotted on the graph because it wanted us to plot Leela's model. So the blue line is Leela's model. Yeah. Right. So Danielle, let me run through the thing one more time. So Danielle, have another person that was introduced. Leela was introduced, and Leela charges differently from Plaxton. So Plaxton would charge you an inspection fee, and then every hour he works, you had to pay him hourly. Leela, however, she would charge you an inspection fee, right? But if you give her the job, she'll give you back the inspection fee, and you'll just have to pay her $90 per hour. Now, in the question, they wanted us to draw a line to represent Leela's model. So, Danielle, if you give Leela the job, you just have to pay her $90 per hour. So, if we want to plot the graph representing her model, we need to figure out some data points, two at least. So let me explain, right? So Danielle, if she works for 1 hour, you pay her 90 because that's her hourly rate. If she works for 2 hours, you have to pay her 180 because 2 hours would have went by, and every hour she get $90. If 3 hours goes by, you have to pay her 270. You understand, Danielle?
Yes, sir.
Yeah, sure.
Yes, sir.
So Danielle, if you don't give her the job, what do you have to pay her? If you don't give her the job, how much you have to pay her? Wait, that's Selma. I'm not hearing you. Selma.
Sir, if
Hey, what is Wi-Fi? It's Wi-Fi have us stressing out, boy.
Well, I ain't have break up too.
Oh, you
yeah,
hear it?
I think
You
it's
hear it?
Yeah, this time is
would I
probably
have to add the
yeah.
50 to it to the $90? Is that wrong?
Wait, Danielle, if you don't give her the job, you'll have to pay her for inspection regardless. So you'll have to pay her 50. But Danielle, what I'm saying is, if you do give her the job, all you will have to do is just pay her $90 for every hour that goes by. She'll give you back the 50 for inspection.
Okay, sir.
So Danielle, if you don't give her a job, but she still inspects the plumbing, how much you have to pay her?
So you're saying if I don't give her the job, so that means I would have to pay for inspection?
Yes. So you'd have to pay over 50. You'd have to pay her $50, right? However, if you did give her the job, how much you'd have to pay for the first hour?
$90.
Would you have to pay for the inspection?
No, sir. Should give you back.
Good. Happy that I understand that. So we'd have used our information to come up with some points. And I would have plotted the points on the graph and get through there. Let me just erase these red coordinates. I would have put this here so that nobody would have been confused when we were doing the original graph. Yeah, just erase it. Okay. Now we have another question. Determine how long a job that returns the same cost for both Claxton's model and Leela's model would take. So we want to figure out the same cost. Same cost. Same cost. So if you see same cost, then you're looking for what? Between the two graphs, you're looking for what? The same cost. You guys hearing me? Yeah or no?
Intersection. Some money.
Wait till I'm gonna try changing my Wi-Fi. Give me a second. Okay, you guys hearing me? Let me know if you guys hearing me. Sound check 1-1. Rajiv to students. Are you all hearing me?
Yes,
Yes,
sir.
sir.
We hear you now, sir.
Okay, I hear it a little better now. So if they want us to figure out how long a job would take to return the same cost for both Blackstone's model and Leela's model, so we're looking for on the graph. We're looking for on the graph.
Where the two lines cross each other.
Intersection.
Yeah, that's what we're looking for. Now it's kind of hard to read from this graph, eh? It's kind of hard to read, but like if you ask me, I would probably say again, it's really kind of hard to say, but it looking like it'd be over here, but that might be hard to read off. Now here this, this graph that I did here is kind of like a guess. Now, in all the copies I was finding online, I was not finding the graph that CXC would have given the students. So I kind of come up with this graph here. It'd be the same concept in the exam, but I just pointed that out. So maybe in the graph, you had a different scale that would have allowed you to easily find a point of intersection. Now over here, it's kind of hard to see. So we'll have to plug in and see if it's correct. You'll see what I mean by that. So are you thinking, well, we could probably try,
5.
you want to try 5? Nah, that can work for sure. That can work.
So it
Nah.
gives the same point, the 490, where the green arrows passing through. That look like where the two lines pass through each other.
It looking so, but I'm not sure. Let's verify it. Let's verify it. We'll verify it. So let me show you guys how you could verify that. So let me explain quickly. So let's just recall what Plaxton model was. This was Plaxton's model. This was Plaxton's model. And let me show you what Leela's model was. Leela's model was C is equal to 90T. It will make so much sense in the end, but stay with me. We had 490 5.5. So, in other words, when you work 409, I was saying, if you work 5.5 hours, how much you'd have to pay?
$490.
Now, if this is the correct answer, it is going to satisfy both equations. Let's see. Well, we know it's going to satisfy Plaxton's model, and we can verify that quickly. So the cost is 490, and so that's going to be 490 is equal to 80 by 5.5, that's the time, plus 50. Somebody plug that into your calculator and verify that again, back 490.
Yes, sir.
Okay, cool. And here what? If it satisfies Leela's model, then this is definitely the answer. So the cost is 490. And what is the time? Okay. Was 90 by 5.5.
195.
495, sir.
So that's not the exact answer. Nah, that's not the exact answer.
Nah.
Nah.
195.
So, and instead of using 5.5 hours, what about if we use 5 hours instead?
Nah, that would definitely not work. That wouldn't work because it doesn't intersect. Doesn't intersect.
Oh,
Yeah, we're looking for a point of intersection. So here what I'm going to do, I'm going to solve it using simultaneous equations as opposed to this graphical method because it's kind of hard to read from the graph. So let me show you guys how you would handle that. So again, it's kind of hard to see what is the point of intersection from the graph because of how the scale is situated. So I'm going to do simultaneous equations quickly. For those of you guys that did not know, anytime you want to find the point of intersection, you could solve two equations simultaneously. How much of you guys knew that?
Mister.
Yes, sir.
Okay, well, let me just use that quickly over here and see where's the exact answer. Because that 5.5, 490 didn't work. And it's kind of hard to read from the graph. All right. Okay, what method do I want to use? Nikolai, if we're doing this using simultaneous equations, what method do you want to use? Substitution or elimination?
Substitution.
Okay,
Substitution.
no problem. So if we are using substitution, we need to come up with that third equation. So we could call this the first equation, and we could call this the second equation. When you're doing substitution, you need to write one unknown in terms of the other one, so you could plug it in, so you end up with one unknown. So tell me something, right, Nikolai? Do we even need to find that third equation for this question? Do we even need to do that?
No.
No, we don't know how to do that. We don't know how to do that. And both of them equal to C.
Yes, sir.
So if both of them equal to C, oh yeah, this looking complicated, right? But here what I'm saying, both of them are equal to C. So they're technically equal to each other. I could put them equal to each other. So Nikolai, I could say 90T is equal to what?
80T plus 50.
Okay, looking like 5 was the answer. But you can't really see that from the graph. I'll try to
Yes,
draw
sir.
back I'll try to draw back the graph a bit neater and we'll see. But 5 looks like is the
so,
answer.
so 5 is the answer because 80 by 5 is 400 and the $50 inspection fee. That is for Blackstone. And for Leela is 90 by 5 is 450.
Cool. So again, the same amount, right? Yeah, yeah.
Yes, sir.
Nice. Yeah. So I'll try to draw back the graph a bit better. But when you work this out, you're seeing that t is equal to 50 over 10, right? And where's 50 over 10? Somebody tell me that. What's 50 over 10?
5.
5.
5. And so when t is equal to 5, it's supposed to give us the same cost. And if you're doubtful, you could plug that back into both of the equations. So c is equal to 90t. T is 5, so c would be equal to 90 by 5. What's 90 by 5?
450.
Wait a Yeah, 90 by 5 is 450. All right, that is Leela's model. Let's check Plaxton's model. So C would be equal to 80 by 5 plus 50. What is 80 by 5?
450.
Well, 80 by 5 is 400 and plus
400.
50. Yeah. Yeah, so that's the answer. That's the answer. T is 5. Yeah. Let me try to draw my graph a bit better so you can actually read it off from the graph. Don't worry, I'll explain this method just now. But let me try to draw my graph a bit better. How I could draw this graph better, boy? That's the question. Let me see if I could draw the graph like 100% perfect. Uh, do any of you guys know about GeoGebra and thing?
Yes,
No.
sir.
All
Yes,
right. Well,
sir.
if I plot the graph in GeoGebra, and it's supposed to be perfect.
Sir, did you say GeoGebra?
Yeah, GeoGebra. You know
Okay.
about GeoGebra, Nikolai?
I don't think I've heard about it. No.
Now, boy, Nikolai, you know about GeoGebra. I would assure you how to use GeoGebra in class. I just always use it to show you demonstrations. Look over there. I'm not sure if you've seen it.
Yes, sir, I could see it. It really does look like it passes 35.
Yeah. So I fixed the graph. You really have to be careful how you draw your graph. So let's look at the question again and make sure everybody understands it. So Videsh, read part 2 for me. Right, I see Videsh join here. Videsh, don't be shy and thing, this is vibes. You could talk. Okay. Can I hear him, Videsh? Okay, I see
Yes,
Videsh
sir.
on mute. Yeah, Videsh, read part 2 for me.
Determine how long a job that returns the same cost for both of Paxton's model and as model would take.
Right, so we're talking about the same cost, right, Videsh? The same cost. So here, this is Videsh. Leela doing a job and Plaxton doing a job. Both of them doing a job at a different rates and different fees. Understand?
Yes, sir.
But we're trying to figure out how much time would have to pass by for both of them to get the same amount of money. Because then you're seeing the same cost. If it's the same cost, then both of them would have earned the same amount of money. So what does that mean when you look at it on the graph? Well, this is about intersection. This is intersection. This is intersection. And you'll see why I'm saying that. So again, Videsh, we're trying to figure out where both of them have the same cost, right? They're getting the same amount of money. The same amount of money. Understand? The same amount of money. You with me?
Yes, sir.
And you understand that two of these people working for different rates.
Yes, sir.
Good. So the red line represents Plaxton. So the red line represents Plaxton's model. This is Plaxton. Don't ask me why the man son, but don't ask me why the man name is Plaxton. I don't know. I low-key feel like he Guyanese. I feel like that's a Guyanese name. I don't know. Let me not say anything controversial. Yeah, Videsh. And the blue line represents Leela's model. Now, are you seeing these lines intersect anywhere? Are you seeing these lines intersect anywhere? Tell me.
Yes, sir.
Where they intersecting?
By 450.
So I'll tell me the x value first. So the x value would be 5. And that would correspond to what? If it's on the x-axis, we're measuring what on the x-axis? What are we measuring on the x-axis?
5.
We're measuring what? Time. I'm not sure if I say time, but time is what we're measuring. And on the y-axis, what are we measuring? What are we measuring on the y-axis? Check the y-axis. What are we measuring on the
Cost.
y-axis? Cost. So can you see that when the time is 5 hours, and both of them, how much money both of them gain?
450.
You understand the question? Let me know if you understand that, Videsh.
Yeah, kinda.
Kinda? Okay. That we can't work with kinda. We have to fully understand it. So, Videsh, they want us to figure out how long a job would take for it to return the same cost for both Plaxton's model and Lila. If we convert in that mojo to English, I'm basically asking you, Videsh, how long both of them had to work for to get the same amount of money? That's what I'm asking you. Understand?
Yeah.
So, how long would they have to work for to get the same amount of money? You understand that? How
Yeah.
long would they have to work for to get the same amount of money? So when you read the graph, how long would they have to work for to get the same amount of money?
5 hours.
5 hours. Because at 5 hours, what both of them getting? Both of them getting what?
450.
You understand it now?
Yeah. Yes, sir.
And if you still had trust issues, let me show you something faster. When the time is 5 and you plug it into Leela's model, this is Leela's model, C is equal to 90T. You're getting 450. When you plug it into Plaxton's model, we're getting
450.
Exactly. So Videsh, if both of them work 5 hours, both of them getting how much money?
450.
You understand?
Yes, sir.
Good. So this question had to do with intersection. Now, graphically, you could look for the point of intersection. The point of intersection on the graph is 5,450. Is everybody okay with that? Yes or no?
Yes,
Yes,
sir.
sir.
No.
Yes.
If you didn't want to solve it using the intersection on the graph because you know it's kind of unreliable, you could have done it using simultaneous equations. So somebody remind me, anytime you solve two equations simultaneously, what are you finding for graphically? What are you finding for graphically? Anytime you solve simultaneously, you're finding for you what? Between two graphs. What are you finding for?
Intersection.
Intersection.
Interception.
Right, I can't stress that enough. Anytime they ask you what value would satisfy both equations or both lines or both, really, anytime you see the word both, just think about intersection, right? Both. So anytime you see the word both and it have two lines, think intersection. Now let me just show you something to seal the deal. So who here know about GeoGebra again? Who know about it?
Me.
Okay,
Oh, yeah,
cool.
yeah, yeah, yeah. Yes, sir, I see it, I see it. I
Yeah,
thought it was
Nicola.
talking about matter. I thought it was
No,
talking about matter and maths.
no, I just show you this all the time in class. So C is equal to 90t. Now, instead of using C and T, I will just use Y and X, right? So I will say Y is equal to 90x. Right? Let me just, okay, cool. So I have that graph over there, right? People on TikTok can't see it. So I'm showing some proof here using GeoGebra. And then we have Y is equal to 80x plus 50. So when I press the intersector, even on this, it kind of had see the point of intersection. All right. Are you see any point of intersection there? Yes or no?
Yeah, yeah. Yeah, I think so.
Okay, when I press the point of intersection, all you could tell me what I'm supposed to get? Anybody could tell me what I'm supposed to get?
You're supposed to get 5 and 450.
Bam, 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 bam. You see? Watch. Badness, right?
Yes,
Badness.
sir.
Yeah.
Just we can't use this in the exam.
Unfortunately. But let me do a quick recap, right? So in the question, they gave you a table. And this table was representative of Claxton's rates and fees. So you're seeing length of our job in hours, and you're seeing the cost. You saw that the cost is increasing as time increases. So it kind of looks like our hourly rate because the cost increases by the same amount, 80. So just from that, we could kind of figure out that the hourly rate is $80. If you were to backtrack a bit and take away 80, you'd see 50. And that would kind of give you the inspection fee. Now, anytime the rate of change is the same, you should already be thinking about a line, a straight line, a linear graph. So the first question was a plot a graph. So I plot the graph. The red line represents Plaxton's model. So that wasn't hard. Part two, they wanted us to state the equation. On the y-axis, we had cost, so I replaced y with c. Instead of x, we had t, so I replaced x with t. The hourly rate was 80, so I replaced m with 80. And the y-intercept was 50, because that's where the graph got the y-axis. So I hope everybody understands that. In part 3, they ask us to state the inspection fee. The inspection fee is just the cost you had to pay one time is 0. So that was 50 as the y-intercept. B, Plaxton received 490 for a job. Determine the number of hours he spent on this job. So what you can do, you could look at the graph, or you could just plug in 490 into the model we came up with and solve for t, and you get your answer. Over here, they mention a new person, Lila. Lila works a bit different from Plaxton, right? If you give she the job, you don't have to pay any inspection fee. If you don't give her the job, you have to pay an inspection fee of 50. But in this question, they said assuming that she's given all the jobs. So if she's given all the jobs, then she just has to pay $90 per hour. So the model there is just C is equal to 90 by T. So every hour that goes by, you got to pay $90 more. So they wanted us to plot the graph on the same graph as above. You want me to previously. So I get 3 points. I plotted the 3 points. Lila's model is in blue, right? So I draw the red line for Plaxton and the blue line for Lila. In part 2, they ask us how long would it take for both of them to earn the same amount of money. And anytime you see a question like that, you're thinking about intersection. You look at the intersection, you see it's 5,450. So when both of them work for 5 hours, both of them are getting the same amount of money. Both of them are getting the same amount of money. Somebody is asking me what y is equal to mx plus c. Y is equal to mx plus c represents a linear relationship. Here what? Watch the video. Watch the video on YouTube and you're going to understand it. We're real into it now, so I don't want to go back to that, but it represents a linear relationship. The YouTube live. You guys are hearing me on the YouTube live? Give me a second. Sound check 1 1. Okay, I'm not sure what's going on with the YouTube live edits. Customization. Okay, I'm not sure what's going on there. Yeah, I'm really not sure what's going on there with the But don't worry,
There's
I'll post.
something wrong with the audio, and it's just showing your face and not showing like the shades, you know.
Okay, well I'll have to work on that. Right? For now, we will just focus on the Zoom, right? Or we will work on that. I feel like it just makes sense to end the YouTube live because like it's just hogging resources on and not working out. People that want to join the meeting, head over to TikTok on the live, head over to the live, and you should find the meeting information somewhere there. Right? But sorry about that. I will work on the YouTube live. Okay, let's continue. So part 2, I need a volunteer for this. Let me just give me a second, share. Okay, you guys see the screen, right? Cool. Somebody get us a
I'm
read.
not seeing anything.
You see the screen now?
Yes, please.
Okay, I want somebody to get us a read from him. Get this question I read.
Ella wanted to determine the characteristics of a great teacher that are important to a group of 30 fifth form students at her school. She asked the students to rate the importance of each of the following 5 criteria using a scale of 1 to 10, with 10 representing a characteristic that is most important and 1 representing a characteristic that is least important. Entertaining, communicative, knowledgeable, caring, easygoing. The students' ratings for entertaining are shown below. You're required to write a description of how the investigation would have been conducted by using the headings provided and answering the questions that follow. Determine the range of the ratings for the data reported above.
Right, so we have to determine the range. So I see Nikolai raise his hand. Nikolai, talk to me.
There's just something to say. You know how she read all of that? You know, like in the English test where you have to do the 5 main points and write a summary.
Yeah.
I'm looking at that, sir.
Real.
Yeah, boy. I don't. You see, paper 3 in maths is like our English test as well because it's application type questions. So you're gonna have to do a lot of reading, which is annoying in maths. So let's answer the question. Determine the range of the ratings from the data recorded above. So does anybody know what the range is? Range. Does anybody know what range is?
Is it for the
Yeah.
highest to the lowest?
Yeah.
Highest
The
minus
lowest.
the lowest?
Is the highest observation minus the
Minus the
lowest?
lowest.
Huh. So what was the lowest score? That was the lowest score from the data recorded above. What was the lowest?
7?
7.
Yeah, and what was the highest?
7.
What's the highest score?
10.
10. So that was going to be 10
23.
minus 7. What's 10 minus 7?
3.
3.
Cool. That was an easy.
3.
That was an easy 1 mark. All right. I feel like we're back in standard 5. Complete the tally and frequency columns in the table below. So if any of you all forgot how tallies work, you're gonna, if you want to write 5, you're gonna draw 4 sticks and then you're gonna cross it. Do you all remember that or no?
Yes, sir.
Yes, sir. Yes,
Okay, good.
sir.
Yes, sir.
Cool. So 7. Let's count the amount of times we saw 7. 7, 7, 7, 7, 7, 7, 7. How much times is that?
7 times.
7 times.
Wow. That's funny. So it happens 7 times. So to represent 7 is going to be 1, 2, 3, 4. Cross that, be 5. Then 2 more to indicate 7. Did you guys understand that?
Yes,
Yes,
sir.
sir.
Yes.
So we recorded our rating as 7 times. So that's going to be 4 with a cross to represent 5 and then 2 more. Cool. 9. Let's count 9 now. So 9. So
3
9,
9. Well, 4 nines.
right, 4 nines. To represent 4 nines is going to be 1, 2, 3, 4. Is there anybody here that's gonna lose at 3 marks?
No.
Nah?
No, sir.
We're sure, right? If there's anybody here that wants me to go over the tally chart, let me know. But everybody okay? Let me know if all are good.
Understood, sir.
Okay,
Like
good.
that person, I fully understand it, sir.
I fully
Yeah,
understand
I
it.
fully understand.
Yeah, boy. So part 3. Using the table above, determine for the 30 students on the entertaining attribute of their teacher the median rating. Okay, this is something that's confused real people, but essentially median is like the middle, data point. So I'll explain what I mean by that. So the median is Q2, and Q2 is going to be represented by half n plus 1 term. So stay with me, it'll make so much sense just now. Okay, let me give you a quick example, right? Imagine I had 1, 2, 3, 4, 5. Could anybody tell me what the middle data point would be? The middle.
3.
3.
That's what the median asking,
3.
That is all the median asking you. The median asking you for the middle value in ascending order. So your data has to be in ascending order, and it just be given by the middle value. That's literally it. Okay, and what if you had like even set of numbers like 1, 2, 3, 4? Could anybody tell me what the middle number would be?
It will be the average of those two numbers.
Yeah. Well, let's see in that the middle.
Average of 2 or 3.
Exactly. So I hope you guys understand why the formula says Q2 is equal to a half n plus 1, because what we ended up having to do here is finding half of 5. Where's half of 5? Somebody tell me, where's half of 5? Half of 5 is what?
2.5.
Right, 2.5. If it's 2.5, that would be in between the second term and the
Third term.
Third term, sir.
Isn't that way observed over here? The middle was in between 2 and 3?
Yes, sir.
Yeah. So the median is just going to be in the middle of your data, and your data needs to be in ascending order. So hope we understand that. So we have 30 students. So n represents the total number of students you have. So that's going to be a half of 30 plus 1. What is a half of 30 plus 1? Somebody tell me. Where's a half of 30 plus 1?
15.5.
15.5. Now here they say earlier that 15.5 is not my answer. Is not my answer. No. Naughty, naughty. If you think that's the answer, no. That tells me where the answer is. It will be the 15.5 term. So that'll be in between what terms? Somebody tell me fast. That'll be in between what terms?
15th and the 16th.
Everybody okay with that? Between the 15th and the 16th term.
Yes, sir.
Yes,
Okay,
sir.
good. Now let me show you guys a very easy way to work this question out. So I'm gonna create another give me a second. I'm gonna create another column and I'm gonna call that cumulative frequency. You'll see why I'm doing this. Cumulative frequency is just the running total of the frequency. If you're confused, don't worry, you'll understand just now. So we starting off with 7, and then if you add the 18 other people, we'll get over here. Okay, so just to make sure we understand this, does everybody understand that frequency tells us the number of people Yeah or no?
Yes, yes, sir.
Yes,
Yes,
sir.
sir.
So when it be
Right.
26,
26. Nah. We 20. We 25.
25, right? My bad.
All right. 25. So let me explain what we're going on here, right? The first 7 people would have give a rating of what? The first 7 people would have give a rating of what?
Yes,
7.
7.
7,
The other 18 people, the next 18 people would have give a rating of what?
8.
8,
8.
Okay, so if you combine 7 and 18, right? Any 25 people over here would have give a rating of either 8 or 7.
yes, sir.
Yes, sir.
Okay, good. And now, if I wanted to figure out the amount of people that give a rating of 9, 8, and 7, how would I do that?
Yeah, add the 4 to the 25.
Just 25 to the
Exactly.
4.
And if I wanted to figure out the amount of people that give a rating of 10, 9, 8, and 7, what would that be? What would that be?
29, 30.
30. So I'm going to go over the cumulative frequency one more time. Just note it's just your running total. I don't mean like Usain Bolt. I mean like you're going to add the frequencies. Cool. So let me start over. So Sarah, how many people give a rating of 7? How many people give a rating of 7?
7,
7. Okay. How many people give a rating of 8?
18,
18. How many people give a rating of 8 and or 7?
25.
Exactly. So I hope all you understand that, If I wanted to figure out the amount of people that would have given a rating of 7 and 8, I would need to add 7 and 18. So that would give me 25 here. If I wanted to figure out the amount of people that give a rating of 7, 8, and 9, how would I do that?
25 plus 4
Good.
to see.
Everybody in class understand cumulative frequency? Yes or no?
Yes,
Yes,
sir.
sir.
Yes, sir.
Yeah,
You're probably wondering, so how are you going to help me here? Well, let me show you, right? The first person all the way to the 7th person would I give a rating of what? Somebody tell me.
7,
Okay,
7.
the 8th person all the way up to the 25th person would have given a rating of what?
18,
Where right 7, boy? Oh, that's not a 7. That's just an arrow. Just an arrow pointing. It looking like a 7, no? Yeah. 8 to 25, give a rating of what?
18,
18? Nah. 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 Wouldn't
8.
be 18. 8. Yeah. 8. The next person, which is the 26th person, all the way up to the 29th person, would have given a rating of what?
9.
Right?
ah,
10,
okay, I
And
see now, my bad.
the last person would have given a rating of what? The last person would have given a rating of what?
1,
10.
10.
10,
10.
my bad.
10.
All right, I'm going to run through this process one more time, right? I go in somewhere with this. If you're confused, don't worry. I go in somewhere with this. So, okay, the first 7 people, they gave a rating of 7. So that'll be the first to the 7th person. Cool. The 8th person, all the way up to the 25th person, would have given a rating of 8. The 26th person, all the way up to the 29th person, would have given a rating of 9. And the 30th person, all the way up to the 10th person, would have given a rating of 30. Well, I say not 30, right? The 30th person would have given a rating of 10. If there's anything confusing you here, just tell me, I'll re-explain it. I'm streaming every day after the 7th of May. After the 7th of May, I'm gonna be here doing free Zoom meetings, free lives every day. So 7th of May. Yeah. Is there anybody that doesn't understand how I did this?
Yes, sir. I understand, sir.
Sarah, you understand?
Yes, sir.
Nah? Nah? Oh yeah.
Yeah.
Yeah? Okay. Nikki, let me know if you understand or if you're confused.
Yes, sir. I understand this.
Okay, Chantel, Romano, Akira, Camille, are you understand?
Yes, sir.
Yes,
Yes,
sir.
sir.
Right, Cassidy, Arlene, Ambika,
Yes.
iPhone,
Yes.
iPhone. I see 2 iPhones in class. Oh, look, I even kidding, right? Watch, 2 iPhones in class. Yeah, we have like an iPhone 16 and iPhone 13 over here. All right. Sidika, Lucas, Avish,
Yep.
CC, Videsh. All you understand this?
Yes, sir.
All right.
Yes, sir.
C CC, Keanu, Reese, Kaylee, Daniela. I have really people here, but all you understand, right?
Yes, sir.
So like our median was in between what value? Somebody tell me. It was in between what? It was in between.
15th and the 16th.
It was in between the 15 and the 16. So where would 15 and 16 fit in? Between 1 to 7, 18, 8 to 25,
8 to
26.
25.
Right. So do all of you guys understand that from the 8th person to the 25th person, everybody would have given a rating of 8, right? Are you understand that?
Yes, sir.
Yes, sir.
So tell me, what would the 15th person have given a rating of? The 15th person would have given a rating of what?
8,
8.
The 16th person would have given a rating of what?
8.
8
8.
as well.
So if both of them given the same rating, right? And the median would just be 8.
Yes, sir.
Yes, sir.
Yeah.
I really hope all you understand that, you know. And here is, while we on this topic, all you want me to explain Q3, Q1 one time or not?
Yes, sir.
Yes, sir.
Okay, no problem.
Yes, agreed.
So does everybody here understand that, okay, the 8th person all the way to the 25th person, all of them given a rating of 8. So in this range, it would also include the 15th and the 16th person. So what does this mean? It means that the 15th person would have given a rating of 8 and the 16th person would have given a rating of 8. So I hope you guys understand that. So if you find 8, so to find for Q2, Q2 would just be 8 plus 8 all over 2, which we know going to be 8. All right. Are they surely understand that? Yes or no?
Yes, sir.
Yes.
Yes, sir.
Okay, I take all the word for it. So I'm not asking that question, right? What did the 28th person give a rating of? Let me see if I really understand this thing. The 28th
9.
person.
9.
28th person.
9.
9.
Right, because I will be in between the 26th and the 29th person. 9. Okay, I see now again good at this. What would the second person have given a rating of? The second person.
7.
7.
Yeah, because that would be in between 1 to 7. Cool. I see somebody join the TikTok with a funny name, boy. It'd be hard not to laugh and think, but anyways. What about the ninth person? The ninth person would I give a rating of what?
The 8.
Are you sure they understand this? I know hearing people like
Yes,
Matthias,
sir.
yeah, Reese, Amelia, Josiah. Once in the Zoom, I like I escape, I here to help all you in any way I could. So I call
So
up
you
on.
can so you can just repeat like the topic because I just joined, so like
Yeah,
I
that
refresh.
that'll be kind of hard, right? So I'll just explain it quickly.
Uh,
You know how cumulative frequency does work? Yeah or nah?
I think so. So I have an idea, but I don't know how to explain it.
All right, so watch. 7 people give a rating of 7, right? So we start off with 7. 8 people give a rating of 18. So 7 plus 18, 25. So what does the 25 mean? So Josiah, the 25 would tell you the amount of people that give a rating of 8 and 7. You understand?
Yes, sir.
Josiah, if I wanted to figure out how much people give a rating of 7, 8, and 9, how would I do that? 7, 8, and 9. How are I doing that?
I'll add it up.
You got add 25 to what?
Um, 25 to 9.
Nah. Tell me, how much people give a rating of 9? What's the frequency? Frequency is the amount of people. How much people
4.
give a rating of 9? 4. So if 25 people will give a rating of 7 and 8, then to add it to 9, I would add 4. Because 4 people give a rating of 9. So
Yes.
29 people would have given a rating of 7, 8, and 9.
Okay.
Tell me something, right? Josiah, the 30th person would have given a rating of what?
10.
Yep. Yeah, it seems like you understand it. Well, what do you think the ninth persons would have give a rating of?
a 9 person, 8.
Big up yourself, Josiah. Big up yourself. Yeah.
Yes, yes, sir. Cause I doing paper three now. I doing paper three.
Okay. Well,
Yeah.
you go check back this recording when I finish. I go over
Okay, sir.
everything in real detail, by real detail.
Okay, sir. Thanks.
Okay, let me look at Q1 now. So to make this make sense, this is the normal distribution for data, right? I'm gonna draw it back. This is the normal distribution for data. Kind of like a hill. This over here would represent Q1, this over here would represent Q2, and this would represent Q3. Now Q2, until you can see that as a median, that cut any data in like at the middle point.
Yes, sir.
So you
Yes.
can see that this is a quarter, this is 2 quarters, which is a half, this is 3 quarters, and this is 4/4. So if all I had to see, Q1 would be like what? Q2 was a half, right? What do you think Q1 is? What do you think Q1 is? Q1 is a quarter. What do you think Q3 is?
3/4.
3/4. Yeah. I really hope all you understand that. So Q1 would be a quarter of n plus 1, and this would tell you the position of the lower quartile, Q1. Yeah, I should have probably say that. This represents the lower quartile. This is the lower quartile. All right, Q1 is equal to a quarter n plus 1. And so, remind me, what was the total number of students?
30.
It was 30, right? It was 30. So if I want to find the position of the lower quartile, that's going to be a quarter of 30 plus 1. Somebody tell me fast, what's a quarter of 30 plus 1? Look, Hassan, boy. Big up yourself. Yeah, where's
7.5, sir.
7.75.
I guess 7.75, right?
I guess 7.5. Okay.
Let me plug that into my calculator.
Oh, no,
I
no,
guess
7.75, sir.
7.75.
7.75.
Okay, let me verify that. Okay, so let me ask you that question, right? 7.75. Really? That would be in between what two values at the end of the day? What two whole values I would be in between?
7 and 8.
7 and 8.
7 and 8.
Everybody down, that makes sense, right? 7.75.
7.
That's gonna be in between these two whole numbers. So it wouldn't be exactly in the middle, right? But it's gonna be in between 7 and 8. Not exactly in the middle, but I'll probably give my point. This will be 7 will be over here, 8 will be over here, 7.75 somewhere in the middle. So 7.75 in between 7th term and the 8th term. Cool. Hope that makes sense. So let's look at our table now. Could somebody tell me what the 7th person would have given a rating us? 7th person.
7.
7.
Yeah, so the 7th person would have given a rating of 7. Could anybody tell me what the 8th person would have given a rating of?
8.
8. So if I wanted to find for Q1,
8.
Q1 would be what?
Be 7 plus 8 divided by 2.
Correct. 7 plus 8 divided by 2. 7 plus 8 divided by 2 is what?
7.5.
Okay, cool. Now I want somebody that's confused to do Q3 with me. If there's anybody that's confused, we could potentially look at Q3 together. Okay. I'm not hearing anybody confused. That's good and bad at the same time. Somebody definitely confused, and they just don't tell them. So we want to find the Q3. So somebody tell me, in the data over here, Q3 is going to tell you the what value? Like the half mark, the 3/4 mark, what? Or 3/4?
3/4.
Yeah, that would tell you the 3/4 mark. So that's going to be 3/4 of n
3/4.
plus 1, right? And we know that the total amount of students here is 30, so that's going to be 31. What is 3/4 of 31? 3/4 of 31, what's that? 3/4 of 31.
23.25.
Again?
23.25.
23.25. Now, the 23.25 term, really, that'll be in between what two whole numbers?
23 and
23,
24.
23 and 24.
23 and 24.
Well, you understand that, right?
Yes, sir.
Yes, sir.
So somebody look at the table and
Yes.
tell me what's rating would the 23rd person have given? The 23rd person.
8.
If you're confused, look at the range. The 8th person all the way up to the 25th person gave 8. So if we're talking about the 23rd person, that would be in between that range, 8 to 25. So they would have given a rating of 8. What did the 24th person give a rating of? 24th person. 8 as well.
Eight.
So to find for Q3, you know that the 23rd term is 8, the 23rd term is 8, and the 24th term is also 8. And so if you find Q3 would just be the average of that. 8 plus 8 over 2. What is 8 plus 8 over 2, guys?
8.
8.
8. Cool. And so, do you guys feel like you know how to find for Q1, Q2, and Q3 now?
Yes, sir.
Yes, sir.
Okay, I want to go over this procedure one more time because it makes it so simple and just students don't fully understand it. The first thing I'd recommend is finding the cumulative frequency. Let's just say run in total. So 7, starting off with 7, you don't need to add to that, so I write back 7. Then I say 7 plus 18, 25. Then I say 25 plus 4, 29. 29 plus 1, 30. The last value for your cumulative frequency should be the total amount of people because you're adding up everybody. If all you notice, what was the number, Sharon? What was the number, Sharon?
30.
It was 30.
30.
If you do cumulative frequency correctly, the last value is going to be the total number because you would have added up everybody. Okay? The next thing, you see the 7 over here? That tells me the first person all the way to the 7th person give a rating of 7. The next person, which is the 8th person, all the way to the 25th person would have give a rating of 8. And I just continuing the pattern over there. And with this, we can figure out Q1, Q2, Q3 real easy. Real easy. So again, here's an example. Q3, 23rd, that's between 8 and 25. You would have give a rating of 8. 24, that's between 8 and 25. Give a rating of 8. So I feel like I'll understand Q1, Q2, and Q3. Yeah?
Yes, sir.
Yeah? Okay. I'm taking all the word for it, I'm taking all the word for it.
Yes, sir.
Again, I'll know if it have anything confusing you. I'm low-key very patient. And so I'll go it over as much time as you need me to fully understand anything. Okay, so I see somebody on the TikTok say do it back. People on the TikTok, I recommend a little go and watch a video on YouTube. But like people on the Zoom though, if you're on the Zoom, you could ask me because I can right here now, I can show you it. Have like a bit of miscommunication with TikTok. Better to do it on the Zoom. So let's just run through the rules quickly. If I wanted to find for Q1 would be what? How would I find the position of Q1? Tell me fast. Quick, rapid speed. Q1.
Of course, and n plus 1.
Yeah, quarter n plus 1. That would tell me the position of Q1. How would I find the position of Q2?
Half n plus 1.
Half n plus 1, bam. Position of Q3, how are we doing that?
3 quartile in brackets n plus 1.
Now, if you get a number with a decimal, like let me just say you get 2.75, right? The 2.75th term, then that number would have to be in between what terms?
2 and 3.
2 and 3.
Country.
So you'd find the average of the second and the third term and you get your answer. So I really hope you understand that. And again, the reason for this is because you can imagine if you have a data set over here and you put down three markers, this would represent the quarter mark in the data. That's Q1. That's why Q1 is a quarter. This would represent the half mark in the data because this would be 2 over 4. Right? 2 over 4 simplifies our half. And well, this would be Q3. This would represent 3/4 of your data. So 3/4 n plus 1. So cool. And with this information, you could find for interquartile range. Does anybody remember what interquartile range is? Interquartile range.
Q3 minus Q1.
Yeah, that's what IQR is. IQR is Q3 minus Q1. How much of you guys knew that? Did you guys know that?
Yes, I knew that.
No,
Okay.
sir, I didn't.
Well, now you know, right? Now you know. So the person that said they didn't know that. What did we get Q3 to be? We got Q3 to be what?
Q3, that would be 23rd.
Nah. That's it. So let me explain it to you quickly, right? This formula over here, it doesn't tell you the answer straight away. It tells you the position of your answer. So when we found 3/4 of 31, we got 23.25. 23.25, that's in between what two numbers?
The 23rd and the 24th number.
Exactly. So now you're going to look at your table, and you see that the 23rd and the 24th number, both of them in that range. So the 23rd person and the 24th person would have get a rating of 8.
8.
Yeah. And so 23rd is 8, 24th is 8. You just find the average of that. 8 plus 8 divided by 2, 8. So that was Q3. And well, for Q1, we found that Q1 was 7.5. Because the 7th term gave a rating of 7, the 8th person gave a rating of 8. So 7 plus 8 divided by 2, 7.5. Oh, look, Mrs. Math Vibes join. Let me not expose you. I wouldn't expose you.
Good night.
Yeah. So Q3 is 8. And where's Q1? Somebody tell me, remind me, where's Q1? Where's Q1? What is Q1? What is Q1?
7.5.
7.5.
So where's 8 minus 7.5?
1.5?
Nah.
1.5.
Nah, that'll be 0.5. Nah, no 1.5.
Oh, yeah. Okay.
So I hope everybody understands how to find the median now, the lower quartile and the upper quartile. And I hope we understand how to find interquartile range.
Yes, sir.
Upper. Cool. Part B now. Oh, somebody's mic is unmuted and we're hearing you.
Oh, my bad, that was me. Sorry.
So, okay, the other part of the question is they want us, wait, they didn't copy, come on a second. Delete this. Okay, let me just copy this real quick. Copy, paste. The other question, they want us to find the average. They want us to find the average. And that is so much easier than any of you all could think of. So when we look at average, right? I'm gonna give all an example. Let me just say we had 2, 7, 9, and 10. How would I find the average for that set of numbers? How would I find the average for that?
Add up all the numbers and divide by the number.
Yeah, so you're gonna say 2 plus 7 plus 9 plus 10 and you divide that by what? What are you gonna divide that by?
4.
Cool. And you get your answer, right? So generally speaking, the average or the mean or X bar is just the total all over the number or the frequency, the sum of the frequency, which is like the total amount of participants. So total number of participants. Or like just total number. So like you see, I add up 2, 7, 9, and 10, right? So I add up all the elements in the set of data and I divided it by the number of data I had. So I had like 2, 7, 9, and 10. So I had 4 data. I had 4 values for data. And the sum of that is 2, 7, 9, and 10. Yeah, you plug that into your calculator, you divide that by 4 and you get your answer. Somebody asked me, what's the difference between average and mean? Average and mean mean the same thing, right? I'll make a little note about it over here. They mean the exact same thing. So average, mean, X bar, all mean the same thing. All mean the same thing. No difference. Just the same way I write, and the same thing. It's like okay. It's like calling somebody pretty. They can call them beautiful or bonita. I mean the same thing. I say that because my girl, Mrs. Math vibes is in the meeting. That's why I using words like that. Yeah. Yeah. It's probably vexed with me. Because I talked to she yet. Okay, everybody alright with everything so far?
Yes, sir.
So I know how to
Yes, sir.
find average now, right? Okay, so if I give all you 1, 2, 3, 4. Yeah, you could use sigma fx over sigma fy. I want to introduce the students to the concept. I want to explain the concept behind that. So if you had 1, 2, 3, 4, how do you find the average for that?
Add them up and divide it by 4.
Exactly. So you're probably wondering where I'm going with this. I really want to teach you guys the concept here. So remember, to find the average is the total amount divided by the amount of people. So when you look at this, how many people got a rating of 7?
7 people.
7.
7.
So if you wanted to find the total amount for that rating, you'd multiply 7 by 7, right? And you will get 7 by what? Or 7 by 7? What's 7 by 7?
49.
Okay. Here what? I'm 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 going to reveal the formula at the end when you guys understand the concept. Because once you understand the concept, you don't have to remember any formulas. Because the formula comes from a concept. If I wanted to find the total amount of ratings, granted that 18 people give a rating of 8, how am I doing that? How can I find the total amount of ratings?
So you can repeat, please.
Okay. How many people give a rating of 8?
18.
So if I wanted to find the total, how am I doing that?
49 plus 18.
Now I'm gonna multiply 8 by 18. Because think about it, 18 people, right? One person, another person,
Oh,
another person, another person, another person, another person. 18 people. All of them give a rating of 8. So altogether, if you want to find the combined rating, you multiply 8 by 18. Or is 8 by 18?
144.
144.
I'll understand where I'm going with this because, like, watch. If the
Yes,
data
sir.
wasn't grouped together wasn't in this format, right? If it was raw data, you will see that you'd have 7 sevens. Then you would have 18 eights. And so you'd have to add all of this and divide it by the total amount of students. It's the same thing we're doing here. So 18 people would have voted 8. So 18 by 8, 144. If 4 people vote 9, how would I find the total amount of ratings for that?
9 by 4.
Exactly. Where's 9 by 4?
36.
36.
36.
Right? And, well, how many people give a rating of 10?
10.
So does everybody understand that what I'm doing here, I'm really trying to find the total?
Yes, sir.
If you're confused, 7 people give a rating of 7. So altogether, that's 7 by 7, that's 49. 18 people give a rating of 8. 18 by 8, 144. So the total amount is 144. And I just do that for the rest. Does everybody understand that? Yes or no?
Yes, sir.
Okay.
Yes,
So
sir.
if I wanted to find the total number, how would I do that? Somebody tell me.
So you just
So
add
add
up
up
the
all.
Add up
I just
all.
I just had to add up all. So I want to add up all. Wouldn't that tell me the total number of ratings, like the sum of all the ratings?
Yes, sir.
Yes, sir.
That's what it would tell me. And then I would just have to divide that by the number of what?
Ratings.
Yeah. How much ratings are at?
30.
30? And that's it? Isn't that the same concept as surely with the 1, 2, 3, 4? A real simple example.
Yes, sir.
It's the same concept. All right. So when you add up all that way again, what are you getting
I
for
got
49 plus 1?
239.
200 and what?
39.
39.
Aha. So if you wanted to find the average, right? So 239 is all the ratings add up together. Now, how much students vote?
30.
50.
30.
Exactly. So if you wanted to find the average, that would just be equal to 239 divided by what?
30.
30.
Okay, and what we get? That's 239 over 30.
7.97.
Yes, 7.
Right? Give me your answer to 3 significant figures.
7.97.
Yeah, 7.97. Now, a lot of you guys would have learned this formula in school, but you really didn't understand why it is do it. So the frequency is F. For those that didn't know, the frequency is given by F. Now, the rating here, this is like what we're measuring. Whatever you are measuring, you call that X. That's the variable. That's what you're measuring. So in school, you would learn that you had to find fx, and then you'd have to find the sum of fx, and lastly, you'd have to find the sum of f, which is the sum of all the frequencies. And in the end, the formula should look like this. And this is what you learn in school: the sum of fx all over the sum of f. Now, the reason why I kept the formula away is because I wanted you guys to actually think and see how they come up with the formula. Or if you like, all you understand how they come up with the formula now, like a little bit.
Yes, sir.
Yes, sir.
Yes, sir.
So let me run it back again. Yeah, here what? So you said the formula total divided by the amount of numbers is for when. Here what, right? That's for mean too. All of it is the same thing. All of it is the same thing, right? It's the exact same thing. The reason why I have to find sum of fx over here is because the data is kind of arranged, like grouped. It's like condensed. It's not raw data. If you look at it, 7 people got a rating of 7. So altogether, if you wanted to find the total number for that, you multiply 7 by 7, 49. So like with this, you first have to multiply to find the total, and then you have to add up everything to find the total. I'm not sure that makes sense. I think I'll understand why I had to multiply the frequency by the rating. Let me know if you understand that.
Yes, sir.
Are you confused?
Somebody say they're confused. Okay, talk to me. I'll go over the whole thing, and you will understand. Trust. But talk to me. Yeah, somebody said they was confused. Okay, let me try to go over the concept quickly. Nikolai, are there?
Yes, sir.
Nikolai, when you find an average, right? Average for raw data. And you will just add up all the data. You add up everything. And you just divide it by the number.
Yes, sir.
Okay, cool. What if I told you the exact same concept here? So tell me, Nikolai, how much people how much people gave a rating of 7?
7.
So altogether, what's the combined rating there? When you add up everything.
It'll be 49.
Exactly. If 18 people gave a rating of 8, how much did they give altogether?
144.
Exactly. Aren't we just finding the totals?
Yes, sir.
How much people gave a rating of 9?
4 people.
So what will be the total then?
36.
Okay, how much people gave a rating of 10?
1.
Right, so if I wanted to find the total number for the ratings, what would I do?
You'd have to add up all the terms that we found out for.
Exactly. And then it would just divide that by the number of students, which is really just the sum of the frequency, because the frequency is the number of students. So when you add 7, 18, 4, and 1, tell me what are you getting? What is 7 plus 18 plus 4 plus 1? What is that? What is 7
30.
plus 8? Exactly, 30. So that's why in school you would have learned this formula, sum of fx over sum of f. The real reason you're using this formula here is because you first need to expand or back the data. You need to see what the total for each row would have been. So 7 people gave 7, so 49. 18 people gave a rating of 8, so 144. So that's why you have to multiply the frequency by way measuring the variable. And that's why you have to add it up, because you want to find the total, and then you would divide that by the number of students or the amount of participants or just the total frequency. Does everybody understand? Yes or no?
Yes, sir.
Yes, sir.
Right. Could somebody in class just tell me what sum of f is quickly?
What did you
What's
say?
sum of f? What is sum of f? Sigma f.
30.
Does everybody understand why sum of f is 30 or not?
Yes, sir.
Yes,
Okay.
sir.
Earlier, if this symbol is confusing you, all it means is I'm gonna add. That is all it means. So like you see how I get 239? That's because I summed. That's what it means. I mean summed. I summed all the elements I got for fx. So that's how I got the 239. And that's what the sigma, that's what the symbol over here represents. It's called sigma. And it's just telling you that you had to sum each element. So 49 plus 144 plus 36 plus 10, you get 239.
Yes, sir.
I'll think I'll understand this or not. If you don't
Yes, sir.
understand it, just tell me.
Yes.
Okay. I take in all the word for it all, you understand, right? So the working that you represent in the exam, you would have said the sum of fx all over the sum of f. And remember, the sum of fx is the total number, right? And to find the total number, you have to multiply the frequency by the variable. So 7 by 7, 49. 18 by 8, 144, etc. You add up all that, and you'll find the total number of all the ratings combined. And then sum of f is just the total number of participants. So that'll be 30. And yeah, you're getting 2.97. So is there anybody, what's in 2.97? That'll be 7.97. Yeah. Is there anybody that's majorly confused by this, or you okay with it? I see Nikolai raise his hand. Nikolai, you understand?
Yes, I understand, but there was a question I wanted to ask. If they would provide a formula sheet, although it's just two questions with a lot of parts in it.
Yeah, they would present a formula sheet. Yeah.
Okay.
But you are given a formula sheet for paper 3. The exact same one you got for paper 2.
Okay. So you don't really, so all this is easy stuff once you know the formula and everything. And
Well,
the formula
Nikolai,
is provided.
you don't even have to know the formula. Because then you understand the concept of it now.
Yes, sir.
Yeah, 7 by 7, 49. 18 by 8. Just add up all of that. Divided by the total. You understand the concept now. That's the most important bit. Yeah. So that's it for these types of questions. Okay, cool. Any volunteers? Part C, any volunteers?
So I don't mind.
All right, give it a read.
I saw Camille unmute her mic, so I don't know if she wants to go.
Camille, let me know if you want to do the question, Mama.
No, sir, I'll do another one.
You're skipping this one. You're skipping this one.
Yes, I feel been so tired.
But ain't if you wait to do another question, Mama, you'll get more tired.
All right, so you're on the phone.
Wait, let me hit you with the vibes. Let me hit you with the vibes. Hit you with the vibes. Hit you with the vibes. Right. So, did the question I read?
The table below shows some statistics for the 5 characteristics
This is
under
math.
consideration.
All right.
Hold on now. Five
Yeah,
characteristics
this will
under
come in paper too.
consideration. Most of the statistics for entertaining are missing. Statistics, minimum rating, maximum rating, mean or average, standard deviation. Entertaining, standard deviation 0.72.
Oh, you don't have
Communicative,
to you don't have to read everything. You don't have to read everything.
okay.
What's
So
up?
leave out the column.
Yeah, that's fine. That's fine.
Okay.
It's a lucky thing they didn't leave out standard deviation because to find standard deviation is real work. Any other remember the formula for standard deviation per chance?
Isn't it the, no, is the square root of sigma f?
Nice. X minus x bar squared
Oh,
all over n. That's what it
okay.
is. That's standard deviation. And well,
I misplaced the x minus x with the f.
no, I don't have no f. Remember, standard deviation tells you how your data varies with reference to the average. So you would have to find x minus x bar for all the data entries. So you see like how far it is from the mean.
Yes, sir.
Yeah. But let me answer this question here because it's real simple. And I don't think they go make it to standard deviation. That's kind of evil if they do. But here what? Everybody here, uh, after the 7th of May, I'll be doing free sessions every single day for like 6 hours and thing. Gonna be crazy, but I'm gonna be here to help all you however I could. Right? You don't know math vibes to the world. and I'll be very, very in-depth. And I'll take my time and I'll make sure you guys understand. You know, we had to pass maths. No, we're not passing maths, we excelling in maths. So Camille, they want us to state the minimum rating for entertaining. This is real simple. What was the minimum rating for entertaining? These were all the values for entertaining. What was the minimum value? Was the minimum value there? Real simple. Promise.
7.
7? That's it? Yeah. What was the maximum rating? What's the maximum rating?
9.
Nah, not 9. Was it 9?
I'm sorry, 10.
10. And well, mean slash average. We find already. What was the average?
7.97.
Yeah, 7.97. Was that hard? Camille, was that hard?
No.
No, Camille. No. You see you
It's
there.
just, it's the words, it's, it's
I
the words.
understand. It looking like a whole English paragraph. I mean, an English essay. I understand. Right, analysis and interpretation of data. Get out, come on.
In order of importance to the students, the 5 characteristics are ranked from 1 to 5, with 1 being the most important and 5 being the least important. Given that easygoing is ranked number 2 and knowledgeable is ranked number 4, rank the remaining 4 qualities.
Or remaining 3 qualities.
Sorry, the remaining 3 qualities.
All right. So, they already mark easygoing and they already put knowledgeable. Okay, cool. So we kind of need to. Okay, here we're gonna happen, right? I would advise you to look at the average rating because in the question. So let's look back at the question, right? Ella wanted to determine the characteristics of a great teacher that are important to a group of 30 fifth form students at a school. She asked the students to rate the importance of each of the following 5 criteria using a scale of 1 to 10. So Camille, do you understand that 1 to 10 tells you how important the students find that part of the aspect is?
Yeah.
So I'll go over that one more time. What does the rating tell us? The rating tells us how important the student thinks that aspect is. So if it's 1, it's really low. If it's 10, it's really high. Are you understand that? So does everybody understand that the rating tells us how important the students think it is? Yeah or no?
Yes, sir.
Yes, sir.
Okay.
Sure.
So let me ask you that question, right? On average, which one had the most important rating? Like the highest rating? Look at that. Which one had the highest rating? Was it?
Entertaining.
Yeah, entertaining. Camille, let me know if you're seeing that.
Yeah.
So Camille, again, if we want to see at a quick glance, what is the most important thing? And the most important one would have like the highest average rating.
Yeah.
So entertaining has the highest rating. Or if I was a teacher in school, I think I'd be entertaining.
Yes, sir.
Yes, sir.
Very.
I probably do some real mad thing. Probably do that. Okay, what is the, and I'll put something to the side, right? Entertaining had a rating of 7.97. Easygoing had a rating of what? Easygoing.
6.97.
Okay. What do you think I should put after easygoing?
Karen. Knowledgeable.
Nah, I should put Karen. So we're looking at the average rating.
Yeah, Karen. Not bad.
Imagine them students care the most
No,
about entertaining, boy. Way boy.
you know what went through my mind? I was like, Karen and easygoing is They tie, so I didn't say that. I was just like, probably the other one.
No, I had to be
Yeah.
Karen. I had to be Karen.
Okay.
Had to be Karen. Yeah. All right. And Karen had a rating of 6.97 as well. And knowledgeable had a rating of what?
3.63.
And was the last one to rate? Was the last one?
Communication.
It says
Yeah. And that one had the lowest average rating. Yeah, and communicative had a average of what? Average rating of what?
3.30.
3.30. Right? Like I promised, I'm going to go over the whole paper quickly. Let me just make sure that I answered all the questions. Here what standard deviation just tells you how spread apart the data is. That's all it really tells you. That's what standard deviation tells you. It tells you how spread apart data is with respect to the mean. So let me give you an example, right? Data with a very low standard deviation would look like that. Data with a very high standard deviation might look like that. So I'm not sure if you see what I'm talking about, but if you're looking at how the data is spread out about the mean, it's a lot more over here. So this would have a high standard deviation. I don't see how that would really help us in this question, because let me explain something, right? In the question, they literally told us that they're asking the students to rate from 1 to 10 the level of importance. That's what they're asking. Again, watch. Using a scale of 1 to 10, the importance. So if we want to figure out what is the most important one, we have to look at the average importance. So hope you understand that. So on average, entertaining had the highest importance, right? On a scale of 1 to 10, entertaining was like the highest one. And then after that we had easygoing, then caring, then then knowledgeable, then communicative. So if you like, I'll get it.
Yes, sir.
Yes, sir.
Yes, sir.
Bet. So let me run through the paper quickly. Right. So in the first, Isaiah, your mic on. All right, I see you mute yourself. Good. All right. All right. So I see somebody said you can look at the standard deviation when the means are the same. That is correct, because it would tell you how far apart and sparse the data is. So let me explain something, right? If the means are the same, you could look at the standard deviation. If the standard deviation is very low, it would have meant that most of the students gave a rating close to the average. But if you had a high standard deviation, then a lot of the students gave ratings kind of like it would have been spread out. It would have been spread out. So that's why you could use standard deviation to make some inferences, right? Okay, and like the person said, the lower the standard deviation, the better. And again, the reason for that is because most of the data is really close to the mean. If you have data that is kind of far from the mean, then it would have meant that some people give a high rating, some people give a low rating. But if the data is really close to the mean, then it would have meant that most of the students give a rating right around the same ballpark. So probably understand that. So let me try to explain that back one more time, so you guys can understand that. So first of all, do you guys understand what standard deviation is? Yeah or no?
Yes, sir.
Yes, sir.
All right, let me see if I get. I would have done this on my class the other day. All right. So let me show you guys what a high standard deviation would look like and a low standard deviation would look like. So over here, you see that this is a large standard deviation. And so if this is the mean, you realize that your data is very spread apart. Are you all seeing that or no? Let me know if you guys seeing that.
Yes, sir.
Yes, sir.
Now, if most of your data is very spread out from the mean, it would mean that some people give like a low rating, some people give a high rating, because it means that the data is spread apart. But if you look at this, right, does the data look like it's spread out far from the mean, or it looks very compact? It looks like it's very close to the mean. If you guys had to say. So this is the mean over here. If you look at the data over there, does it look like the data is very close to the mean or far from the mean? If you guys had to say.
Close.
It's
Close.
close. And if most of your data is close to the mean, it would have meant that most people give a relatively high rating or a relatively low rating. I'm not sure if I get what I'm saying. So like, let me give you a quick example, right? Say for instance, people give a rating a 1, wait, let me just say somebody give a rating a 9, 10, 8, 7, 10, 8. When you look at all of those values over there, those ratings, and all of those ratings kind of high.
Yeah.
And so when
Yes,
you
sir.
find the average for that, aren't you gonna get a high average?
Yes.
Yeah, you are going to get a high average. And because most of the data points were very close together, if I tell you it have a low standard deviation, you can kind of figure out that most people give a high rating. But let me show you something. Let me just say we had 10. We had 10 and we had 1. Some people are beef with this aspect. So they don't care if they're entertaining or something. 10, 10, 1, 3, 3, 1, 10. Aha. Look at this. I want you to compare that data to this data. Now over here, the data is really, really close together. It's really, really close together. So the standard deviation will be very small. Because if you find the average, the values are going to be very, like it's going to deviate slightly compared to the mean. Because most of the data is like around the same. But over here, if you look at this, let me ask you that question, right? If you look at this, do you think that would have a high standard deviation or a large standard deviation? What do you think?
Large. I.
You'd have a large standard deviation. You know why? Because look at the data. Somebody voted 10, somebody voted 10, then somebody voted 1, a 3, a 3, a 1, and then a 10. So if you find the average for this, somebody find the average for that fast. Find the average and tell them what you're getting. 10, 10, plus 1, plus 3, plus 3, plus 1, plus 10, divided by 7. You should be getting 5.4, 3.
Yes, sir. That's what I got as well, sir.
Yeah, so the average is gonna be 5.43. But don't you have data that varies a lot? Like, okay, some people vote 1, some people vote 10. So can you see how spread out the data is? The
Yes,
average
sir.
is 5.43. Some people vote 1, some people vote 10. So if the standard deviation is large or high, it tells you that the data is very spread out with respect to the mean. Hopefully you understand that. So what? 5.43. The lowest will be 1, highest will be 10. Over here, I want you to find the average for this. I find the average for those data. So 9, 10, 8, 7, 10, and 8. Find the average. 9 plus 10 plus 8 plus 7 plus 10 plus 8 and divide that by 6. Let me know if I get something like 8.67. Okay. Now, when I ask you what is the lowest value there, we're going to tell me. What was the lowest value somebody say? What's the lowest value?
7.
What was the highest value?
10.
10.
Aha. So what was the data? Was the data spread out that much compared to the mean, or was it close to the mean?
Close, sir.
Closer.
Right. So this would have a very low or small standard deviation because most of the data is like really close together. But over here, though, you're seeing that the mean is 5.43. And you can see that some people vote 1 and some people vote 10 on either ends of the extreme. So you can see that the data here is spread apart. So this would have a very large standard deviation. So that is what standard deviation tells you. This would have a small standard deviation, and this would have a very large standard deviation. And I feel like all you understand the concept of standard deviation.
Yes, sir.
Yes.
So that's why the person on TikTok would have said that, if the mean is the same, you could look at standard deviation. because the standard deviation would tell you how close the ratings were together. So that's a brilliant point brought up by that person, right? Cool. So you know what? Let me look at the standard deviation first now and see if we notice anything. So Camille, both of these here had the same mean, right? Yeah, they're the same mean.
Yeah.
Okay. What was the standard deviation for easygoing?
1.01.
What was the standard deviation for Karen?
1.23.
Which standard deviation is higher? Easygoing or Karen?
Karen.
Exactly. So it would have
No.
meant that,
Oh, yeah.
yeah. So it would have meant that the ratings for Karen were a bit spread out. But the ratings for easygoing were really close together. So it would have been a bunch of high values. I wonder if you understand now.
Yeah.
So Camille, one more time. So the higher the standard deviation, the more spread apart your data is. The lower the standard deviation, the closer the values are together. So if you have the same mean, right? You have the same mean, but you have different standard deviations, you're looking to see which one has the lower standard deviation. Because the lower standard deviation will tell you that the data is like really close together. Because Camille, which instance do you think is better? People say 9, 10, 8, 7, 10, 8, or 10, 10, 1, 1, or 10, like that. Which one? If people was given a rating, which rating would you rather? This rating or this rating? If somebody rating your business or something, which rating you prefer? Rating 1 or rating 2?
Rating 1.
Exactly. Are you understand what I mean? If you run in a business, would you want people to leave reviews like 9, 10, 8, 7, 10, 8? Or would you want them to leave reviews like 10, 10, 1, 3, 3, 1, 10? What would you prefer?
Second one.
So I would prefer option 1.
I would prefer option 1. This is, here they said, this is raw. Let me explain something. So if you run in a business, do you want to have a 10-star rating, a 10-star rating, and a 1-star rating? Then wait a moment, my laptop gonna die. Ooh. Okay, I saved it last minute. Nice. Yeah, so the person that said option 2